Hello and welcome everyone to not just a new episode, but a whole new season of the WeAreDevelopers Live Days. Yes, that's right, we are back after our summer break. Well, let me rephrase that. It wasn't actually a break as we weren't idle. We were busy with our World Congress, which took place in July in Berlin, and we welcomed about 12,000 developers there. So we really had a blast. And we also want to give you, the live day audience, a little goodie back. So I can announce here and today that the World Congress will be back next year, also in July, exactly from the 17th to the 18th, again in Berlin. And via the code we provide you in the chat, you will get a 10% discount. To get this, just go to worldcongress.dev, where you get further information about the upcoming World Congress, and you can claim your early bird tickets. And now, before we start with the first speaker of the day, a quick reminder for our reoccurring viewers and quick info for the newcomers. During the talks, you can interact in the chat to your right. If you got some questions, submit them via the Q&A function, but as always, be nice to each other and respect each other, as we have a code of conduct. Here's a short video about it. And what would be a better way to start the new season with one of the classics, Java? And our first speaker of the day can tell us very much about it, as he is developer advocate at Sonarsource, and he marks the release of The Secret of Monkey Island, yes, the point-and-click adventure from LucasArts, as the starting point of his developer career. Welcome, Jonathan.
Thank you very much. Thank you very much. And I'm very happy to have the opportunity to talk to the WeAreDevelopers community.
Yeah, we are very happy to have you, Jonathan. Well, before we start, would you mind telling the audience and me a bit about what we're going to learn from you today?
Sure. Well, next week, Java 21 is going to be released. But there's a lot of people still in Java 8 or Java 11. So they are losing a lot of features and probably a sense of urgency on moving to a new LTS. So I'm going to show which are the features, opinionated list about the features coming from Java 11 to Java 21. And I will explain why and what is a LTS.
Jonathan, that sounds like the perfect topic to start off a day like this. You got my full attention, and I'm sure that of the audience also. And I would say, without further ado, the stage is all yours.
Thank you. Thank you very much. Well, next week we celebrate Java 21. It's a number, so 21 versions. It's been quite a while, Java being out there. And for those that were thinking Java was slowly dying, definitely no. Java is more alive than ever, and we are going to see features that are coming, that are still there, but the power of the community behind Java. But I want to start with a number, that it is 33%. And this number is exactly the number of production environments still on Java 8. Java 8 has, well, few years already, but we see that companies are not moving to new releases. So they are in a safe approach, let's say. But let's think about what it is safe here, because we could think that safe is because they are avoiding the process of migrating and moving to a new version. But on the contrary, staying on this old version means you are suffering from a lot of bugs that are in those releases, CVEs not covered that are in those releases, and lack of performance. So the newer versions have better performance. So one thing that we could use in order to justify that we don't migrate is to be safe. Probably is not that safe. Let's see. I'm here to talk to you about the features coming from Java 11 LTS to Java 21 LTS. I'm going to cover only those features that are in final stage, so not on preview, and covering the most relevant, at least for me, features for those releases. Again, let's celebrate that next Tuesday, we are going to have Java 21 as the final released. So I'm Jonathan Vila. I'm Java champion, and I have a long-time relationship with the Java community. First, because I've been one of the leaders of the Barcelona Java user group since 2012, and also co-founder of JVCN Conf and DevVCN. Those are conferences that we host in Barcelona every year. I've been developer, as it was said before, since the first release of The Secret of the Monkey Island, so 30 years ago. And I've used several languages, coming from Pascal and C, because I had a boss that said that not move to Windows, because Windows is a temporary solution and it will die in a few years. Probably he's not a good forecaster. So apart from that, I moved to Delphi. Okay, I don't know how many of you have used Delphi in the past, but it was an amazing language. But I've also used Golang last year, and now I work as a developer advocate for Sonar. If you want to follow me, you here have the Twitter handle, but also you can scan this QR code and you will have more information about me. And yeah, I work for Sonar, but what's Sonar? So probably some of you already know it because of SonarQube product. But Sonar is or intends to be the home of clean code, helping companies in order to, with tools and methodologies in order to fulfill this clean code concept. They have SonarLint as a free plugin for IDEs, in most of the IDEs, and it will analyze your code as you type, and you will see which are the issues you're introducing. And it's fine, not only because it will help you to fix those issues, but because it will help you to learn, because it has great information about why is that an issue and the ways to fix it. And even more links if you want to explore more about the issue. But also you can download and use free SonarQube on premise if you want to scan several projects. And if you want to go to a hosted solution, then you can use Sonar Cloud, that it is free for open source projects. Several foundations are using it, Apache Foundation, Eclipse Foundation. So you can use it too for your open source projects. If you want to know more, just please go to sonarsource.com or just simply ping me and I will be more than glad to talk about this. But let's talk about today's presentation? Well, basically, I'm going to give you a brief description of what's out there. So, which are the different JDKs versions that are used in production? What's an LTS? It seems obvious, but I've seen that there are some misunderstandings about what's an LTS and a lot of knowledge that have been lost on the way. And I think it can be interesting for some of you. Definitely it was for me in order to investigate it. So it was fun. So I want to share it. And then I will cover different features for Java 11, Java 17, and Java 21. Remember, next Tuesday, it's the final release. Finally, I will give you some conclusions and references that I think are very, very helpful in order to know more about the Java ecosystem and the different versions, LTSs, vendors, and supports. So just take a look at them. Also, you can check the slides right now if you scan this QR, or if you go to the link that you will see in every slide. You can go there, check, explore, click the links, whatever. So let's start. So according to New Relic JVM ecosystem report in 2023, there is a situation that, to be honest, I didn't expect. So from past years, Oracle, Adoptium were massively used as the JDKs. But apparently now, Amazon Corretto is the JDK distribution most used in production, followed by Oracle. Then Adoptium, Red Hat, and others like Azure. So definitely, people are taking decisions, are checking those JDK vendors in order to find which is the best JDK for them. It's not only about Oracle or even Adoptium. You need to check because different vendors offer different time support, different features. Even they have features that are only for those JDKs, obviously, but they are increasing the performance. And even they offer JDKs for different operative systems that can help you on your production. So definitely it's interesting to pay attention and which is the JDK vendor that you're using and if it's the right one for you. Just considering that the JDK vendors support is not the same across the different versions. So we see that, for instance, Corretto has longer support in Java 11. It has similar support in Java 17, but has longer support in Java 21. Oracle, has similar support than Temurin, Eclipse Adoptium, but has lower support in other versions. So definitely you need to check which is the right vendor and just to know which is the support that you are expecting and which are the features that you are going to get, and even the different commercial support that you can buy if you want to. Regarding the JDK distribution regarding versions, I started showing which is the number of production environments in Java 8, 33%. But in Java 11, it's 56%. So there's a lot of people not yet in the latest Java LTS version, Java 17. So there is a lot of work or a lot of environments that definitely will take advantage of new features, bug fixes, performance if they move to newer versions. Even if you run older Java code with newer JDK, you will get a lot of benefit too, just for performance. It definitely it's important to consider to move to the next LTS version that you can. I'm not saying you need to be on the wave, so constantly moving to the new LTS version, but definitely considering the migration to a new JDK as part of your backlog. As you can see here, well, we have Java 8, the first LTS, that will have, well, I'm here considering Temurings only, support until 2026, but Java 11 will finish next year. So it means that most of the production environments, more than half in Java 11, but more than a third on Java 8, are going to lose support in 2 years, more or less. So it's something that it's important to consider. For those 56% that are still in Java 11, they are going to lose support next year. For Java 17, support ends in 3 years, more or less, and Java 21 will finish the support in around 5 years. So it's important at least to move to Java 17, that you will have few years still with support, but then move to Java 21. It's important to know this support lifecycle in order to migrate to the right version. I've talked about support, LTS, but is it clear what it is, an LTS? Well, LTS stands for long-term support. But basically, it's a marketing concept. So Oracle defined it, and then every vendor is trying to align to that definition of long-term support. But the content for this LTS depends on every vendor. As we've seen, different vendors are offering different length of support for each LTS. Now, the cadence has moved to 2 years, well, from Java 17 to 2 years. Before that, it was 3 years. But again, it's an Oracle definition that a lot of vendors are being aligned to it. But it's not mandatory. So you could find a vendor that it is not aligning to this definition of long-term support, or they have their own long-term support definition that doesn't align with Oracle's. Even Azure has a different approach. So they have LTS to be aligned because it's like a marketing thing, but also they have MTS, so medium-term support. So they define the rules differently between the vendors. For how long an LTS has support? Well, usually in between 6 and 7 years. Depending on the vendor, you will find a length. And vendor and the version, you will have a different length. And which is the impact of an LTS in your development? Well, obviously, every new version has a lot of bugs fixed. So that's one point regarding migrating from each version. They can have performance improvement. Yeah, definitely. They have new features. That's for sure. And also they can have some vulnerabilities fixed. Every 4 months, OpenJDK reports CVEs and how they fix them and how they backport those CVEs to the different versions. But also you can find commercial support on LTSs mainly. So definitely it's important to be updated in terms of the Java version, because all of those things apply to every version. But having longer and commercial support is something that impacts definitely in an LTS. That's why it's important to at least be on one of the LTSs. Now that we have clear when Java 21 is going to be released, how many environments are there in which versions and in which vendors, and now we know what's an LTS. Let's discover which are the features for each of the Java versions. We are going to start with Java 11, and I've selected 7 features. New string methods, new file methods, a new method to convert a collection to an array, the not predicate method, a new HTTP client that covers HTTP 1.2, running Java files directly on the command line, and TLS 1.3 support. This Java 11, according to the OpenJDK bug system and the CV's 4 monthly report, it solves more than 500 bugs and also more than 100 CVEs. So definitely, people in Java 8 are suffering from all those bugs and CVEs if they have not been backported to Java 8. So let's continue with, well, what's the new Java HTTP client? Well, the previous one was basically covering HTTP 1.1, and it was working only on blocking mode. So they created a new one that now is supporting HTTP 1.2, and it also allows non-blocking behavior. It's very easy, just simply using HTTP request and HTTP client with builders, and you create the request with the URI, the headers, and the method that you're going to use. And then with the client, you send that request and obtain a response. It's very easy and very fast to develop with this new approach. For each of the features that I'm going to show, you will find the GEP on top link that you can click and explore exactly the official definition of those. For those features that are not covered by a GEP, I'm linking to the bug system of OpenJDK where they describe the new feature. In Java 11, so before Java 11, we needed to do compilation and then an execution. And now with Java 11, we can directly use Java in order to run a JavaScript. It will compile and it will run the Java file. New changes on string methods. Is blank in order to check if it's empty or only contains spaces. Lines in order to return a collection, a list of the different lines using the new line characters. A strip that will remove the spaces in front and on the back. Strip leading and strip trailing if you want to remove the front spaces or the back spaces. And repeat in order to repeat n times the same string. For new file methods, now we have the write string and the read string directly from the file, and it will return a file. So it's in order to reduce also verbosity, and now it's easier. Collection to an array. Before, we needed to use collectors, and now it's simply to array, and that's it. It will return an array. The not predicate method, well, it's exactly the opposite of being a predicate. So if we want to filter those that are not an expression, then we can use the predicate not. It's very, very easy, also very, very important. And it also covers TLS 1.3, but not completely. Some of the features, here are the list of the features covered, and there's no need on modifying the code, just only adding a new protocol, as you can see here, TLS B 1.3, and that's it. So no need to change your code, and it will support TLS 1.3. Not completely. There are few things that are not covered. Regarding Java 17, well, in this case, I've selected 13 features coming from the different intermediate versions. And it fixes around 50 CVEs and more than 500 bugs. And coming from Java 12, we have, again, a string new methods. There's a new method 2 for file, a new teen collector, compact number formatting that gives human reading format to numbers. With Java 14, we have helpful null pointer exceptions where we have information about which was the variable that was causing the null pointer exception. Expression switch. So now we can have switch used as an expression. So directly we can assign a variable to the returned value of a switch. And then we don't need to use the break command in order to avoid that this two different conditions have been executed because we forgot to add a break. From Java 15, we will have text blocks in order to have multi-line text variables. The new ZGC garbage collector. And from Java 16, we are going to have another human readable format for dates. Another method directly converting a stream to a list without using collectors. The introduction of records that are data handlers that will give several features that before we needed to create. So now it's, again, reducing the verbosity and also incrementing the security because it's introducing immutability in these elements. And pattern matching for instance of. So now, again, reducing verbosity because we can have in one single line the casting and checking for the inheritance of an object. Java 17 with sealed classes where we define, well, the boundaries of a class. Let's say who can extend or implement a class and avoiding that any others cannot do it. So, well, we will see in a second. So regarding the new API methods coming from Java 12, we have indent and transform. Indent, it's obvious, in order to introduce spaces on the left. And transform, that now for a string, it accepts a function that will be executed for that string in order to return a transformed value. For files, we have mismatch that will check if two different files are the same, and otherwise, it will return the first character that is different. Again, reducing verbosity and making things more consistent because everybody will use the same approach. The teen collector, in this case, is a collector that uses two collectors and a merge function. Basically, all the elements will be passed through the first collector and again to the second collector. And the result of those collectors are going to be used in the merge function. In this case, it's a direct usage, easy one. It's in order to calculate the average of a list. So with those two collectors, one collector is summing, the other collector is counting, and then the merge function is dividing the sum by the count. Very easy. And again, it's also reducing verbosity and incrementing consistency, because with this, everybody is going to use the same approach to the same problem. Regarding the compact number formatting, well, it's in order to, again, consistency and verbosity. So in some cases that we need to put on screen or whatever, a human readable number, then we needed to transform 1,000 into 1K if we are using, I don't know, money or basically money. And also if you want to be more human readable and you want to convert 2,000 into 2,000. So instead of everybody doing their changes, with this, we are going to have exactly the same and in a less verbosity way. Again, more consistent, because everybody should use the same approach in order to give a solution for the same problem. With null pointer exceptions, well, it's been a problem in the past where you had lines with different elements, objects being taken into consideration. And when you received a null pointer exception, you knew the line that was causing that issue, but you didn't know which was the variable. So with the example on the top, if that gives a null pointer exception, we don't know if it's A, B, or C who is null. So in order to help us to fix issues faster, or at least to know the information to fix them faster, now we will have the same null pointer exception, but it will contain the description of which is the field that is causing the field, because the object that it is causing the null pointer exception. On Java 14, we needed to enable this. So it was disabled by default with this property. But from Java 15, this is true by default. Also, we have, coming from Java 14, the switch expression. So it's, I think this code is self-explanatory. So on the left, we have a switch that we use in order to have how many letters are in each day of the week. In this case, we could miss the break on the Sunday part, and definitely the result would be different. And it would be hard to get which is the error. And also, we need to have, in this case, an intermediate variable that it is assigned every time, and then having breaks, and then doing what it's doing. In this case, we could even directly, so on the right, I'm using the same intermediate variable just to make it clear, but we could simply remove that intermediate variable and use it in the print line. We would get rid of useless intermediate variables that we should not use, but also it's way clearer what it's doing, and we are reducing the possibility of introducing an error because we missed one break. On the right, we don't use breaks. So it's very clear, faster, and we are reducing the complexity of the code that it's also very important. So this feature for me, it was important because I think that apart from being a smart developer that can do amazing, tricky things, it's super interesting that the code is clean. The code is easy to be read, and it's easy to get which is the real intention of the code. And also, it's hard to introduce errors. So this definitely is a good feature in my point of view. Also, Java 15 is introducing ZGC. I don't know, it's ZGC, ZGC, I don't know, you can pronounce it however you want. And it's a scalable low latency garbage collector that also accepts concurrency. This is a new garbage collector that from Java 17, you don't need to define the number of threads that you want to use. It will dynamically scale up and down those threads automatically. The important part here is that you should define the max heap. So there are different techniques and different things that you need to consider in order to define the heap. But it has, the important thing here is that it has sub-millisecond post time. So it's very fast and it doesn't have big post times as other garbage collectors. Definitely it's nice to take a look and see if it fits for us. Depending on the usage, a garbage collector is more productive than others. In this case, is when you have very huge heaps. Then, well, again, check the different garbage collectors and use the one that fits best for you. Regarding text blocks, another important feature, well, before that, we needed to do, there was a feature that allowed us with the tick to introduce different lines of text, but this has been removed, and it's followed by text blocks. So now with 3 double quotes, we can introduce different lines, and it will respect the spaces and the lines. To be honest, I didn't know about these 2 features, and I discovered it the other day. So, and I think they are important. So if you add backline I don't know, backline S, this will add a space. So we are, because if not, the spaces that are on the end are removed. So with this backslash S, we can introduce explicit spaces on the right. And also we can even remove new lines. So we can have new lines just for the sake of being more readable. But we can say to Java, okay, but this line is only to beautify it, don't use it. With a backslash, it will remove the new line. So it's interesting, especially if you are using, well, HTMLs, XMLs, JSONs inside your code. Definitely is a good feature that will allow to have beautified long strings. Coming from Java 16, we have now the pattern matching for instance of. In this case, well, again, it's an important feature to reduce verbosity, but also to make more consistent the usage of this new feature, making that everyone will use the same, because Java is providing the way to do this. In this case, if we want to check if an object is an instance of string, we need to use this instance of that it is only a Boolean check. And if it's true, then we need to cast the object to the type. That's redundant, right? And then use it. Now with the pattern matching, it is doing the check and the cast in the same line. So just doing instance of string s, that it is the the variable that has the object in the type that we are checking, and then we can use it. Another important feature now coming from Java 16 is records. Records are providing, again, consistency and less verbosity to Java. Before that, we needed to create a class that was defining the fields. Also, we needed to create the constructor, the accessors, the equals, the toString, the hash code, different methods, and it was not immutable. Well, we can do it immutable, but it's on us to do this. But now we have records that are immutable. They are final, so you cannot extend a record, and that provides out of the box all the same features and methods that we have on the left created by our own. And again, it's creating consistency because everybody now will use the same approach. When you see a record, you know exactly that it is an immutable data, a final data element. But on the left, you know that it is a class point, but you don't know if it is more than a simple data element. So again, reducing verbosity and adding consistency to the language. With Java 16, they period support with this formatter where we can just have this human readable 3 in the afternoon. We have different options in order to have different lengths, but yeah, it's adding human readable format to dates. With Java 16, we have the toList that before that we needed to have a collector and collect to a list. Now the streams are already having the toList that will return the list. Again, reducing verbosity and adding consistency. Sealed classes are a way of defining who can extend or implement a class. But even we can redefine in the middle of a hierarchy that feature. So in this case, we have shape, that it's a sealed class, only allow it circle, rectangle, square, or weird shape to be the ones that are implement or extend. But then we can define a rectangle that it is a non-sealed class that extends shape. So the rest can implement or extend rectangle, but not shape. So also this is important to define boundaries for our classes. And ending with Java 21, I'm having 6 features, and this is fixing 8 CVE fixes. I still don't know exactly how many bug fixes we'll have until next week, but I will update the slides. From Java 21, sequenced collections, record patterns, pattern matching for switch. Virtual threads is an important feature, and prepare to disallow the dynamic loading of agents. We will see in a moment. Code snippets. Now we can introduce code in our snippets, and this will be considered as code from the linters in the IDE, and also it will be generated as beautified code when we generate the Java documentation. Sequence collections, well, it adds the ordered approach to collections and the same methods for all the collections. Again, adding consistency and reducing verbosity, because now we have add first, get first for collections. For sorted collections, we have reverse that we didn't have before. And the same for sorted maps and linked hash maps. It's the consistent way of doing the same thing for all the collections, and also reducing verbosity. Disallowing dynamic loading of agents, well, we use agents for telemetry, I don't know, New Relic, Dynatrace, and others. But now they are, they will be forbidden if there is not explicit as property enable them, just because they can use backdoors to do whatever with your code. So now you only get a warning, but in the future you will get it won't work. You need to enable them explicitly. Record patterns, well, it's the same instance of, but now with patterns. Before we needed to do the instance of, and we had the variable with the same type, and now we can even have directly the fields of a record. Virtual threads, because before we had physical threads that were limited by the operating system, but now with virtual threads, we have different virtual threads mapped to one physical thread. Therefore, we can have millions of virtual threads. And every time that a thread is using EO and is a blocking call, that thread will be used by another virtual thread. Therefore, we can have way more performance with virtual threads. Pattern matching for switch. In this case, well, we have, again, reducing the verbosity because we have switch directly in each element, comparing the type. So it's very easy now to do different things depending on the type of an object. And finally, I want to finish with my conclusions. Apart from being a list of different features that you can go back offline and check one by one, it's important, my message, it's that LTS is a version to use in production. It's important. Most users are in Java 8 or Java 11, so there's a lot of work to do again to move them to Java 17. Take the advantage of doing that. There are several vendors offering different supports and different features, so better to check them. Now the LTS cadence is 2 years, but who knows? Oracle decides. And every version improves performance. API also reduces bugs and CVEs. And the most important message here is that Java is alive and free, and a lot of people behind it. And finally, here are some references in order for you, if you want to explore more about this topic. It's been a pleasure. Thank you very much. Here you have the QR code for the slides. And also, please, por favor, if you can rate me with the QR on the right, it will be super important for me in order to improve. On the left, the ways to contact me, my Twitter handle, my email. You can see some of my posts in my blog and also my code in GitHub. Thank you very much and hope you enjoyed the talk.
Hello again, Jonathan. Thank you so much for this very informative talk. I think you maybe convinced some people to move on to a more current version of Java. Even it's maybe more comfortable to stay with the old you're used to, but I think you made some good points during your talk.
Okay.
Kudos for that, of course. Thank you. And since we have some minutes left, let's jump into a quick Q&A, I would say.
Mm-hmm.
And if you're ready, first question to you directly, maybe about you yourself, your developer journey. Would you mind to enlighten us a bit on how you became interested in tech and what was like, what were some jobs you did during or since The Secret of Monkey Island?
Well, it's interesting. I started when I was 14. Because I wanted to do games. At that time, I had an Amstrad CPC. And, well, before that, I went, I asked my father to take me to a shopping center every Saturday afternoon, because there they had a lot of computers exposed. And I was sitting there with my magazines, and I was poking games and doing things in those computers. After that, I had one Amstrad CPC, and I was spending a lot of time doing, well, small games, small applications. And from that, this is the only thing that I've done, being as a developer, moving from different languages, because every company had some language request when they are hiring, but then once you are inside, they move to different languages. And so I've been moving in several languages. But I would say the most important point in my professional life was when I discovered the Java community. In 2012, before that, I was working 9 to 6 every day. Well, 9 to 7 at that time, every day, and going home, and that's it. But then I discovered, because I had a problem with the Spring and I needed help, I discovered the Java community. And since that, my professional life changed dramatically. I saw the power of community, a lot of knowledge, a lot of amazing people in the community, sharing information for free, learning a lot, and knowing that there's a huge world out there. And then from that, I moved to different companies. I would say, yeah, most of them in English, some of them remote for the last 6 years, more or less, full remote. And from 2012, I discovered that I loved community. And from that moment, I've been working as a developer, but now I knew that I needed to change. So 5 months ago, I joined Sonar as developer advocate, sharing knowledge with community, going to talk to developers. And this is what my passion is. And now I have a salary based on that. So that's amazing too.
Awesome. Happy to hear that, Jonathan. Yeah, I can tell that you love sharing your knowledge, and I see where it comes from, coming from all these tech communities. Yeah. Awesome. Thanks for sharing this. And I would say let's go on to some of the more technical questions, as one of our viewers wants to know. I've used Java since 2007, seen it rule web, mobile, desktop. Now, desktop and mobile lean towards Kotlin, Node.js, Python are trendy due to simplicity and popularity. Many tasks are simpler in Node.js. What's Java's future in this context?
Well, I have to say, well, you know, that common saying that says this year is the year of Linux on desktop. But we can apply the same with Java. Definitely one thing is the trend, and another thing is the reality of companies. But another thing is what can be done with the languages. So the trend, well, the world of JavaScript and TypeScript and all of those libraries is a constant trend. Every year, a new library appears. So it's creating a lot of traction. That's one point. Definitely, it can be easier. Well, we could argue about that. Then there's another point, that it is why a company is using a language. So if they have front-end developers and back-end developers, then this can stay forever. Therefore, there's no space for Java into that space because, well, you cannot convert the JavaScript developers into Java developers, or it will take some time to do that. But Java can be used on the front end, especially if you are using websites, JSF, I don't know, Prime Faces. There are different libraries that can offer you a lot of power to, and big companies are using them. But there is also another technology that I especially like, that it is Vaadin. Vaadin can create front-end applications, web, desktop, a lot of environments, and you use Java, only Java. But it's not very, or it's less explored than other offers. So definitely it's not a problem that Java cannot be there, but it's that Java hasn't been there. But in some companies, they are using Java for doing their front ends, and the same developer can implement the front end defined by a UX, and also can implement the backend. So definitely, Vaadin is a technology that it should be taken into consideration. Hope I answered your question.
I think so. Thanks for that. And the next question is also maybe a bit connected to this one. You told us during your talk a lot of the new features from version 21, but what feature do you still miss in the upcoming version 21?
What feature I still miss in Java 21? Wow, it's an interesting question. I don't know. I think one thing, in order to reduce verbosity to Java, is well, I know that I'm entering in a complicated path now, but okay, forget it. I will say it. Some features from libraries like Lombok that are reducing the verbosity for the developer, I think they are also important, because we have accessors and mutators in Java, for instance, and following the convention makes your classes having lots of accessors and mutators. Probably records are fixing some of this because they are implementing behind those accessors. But I think for the Java language, it would be also interesting to reduce even more the verbosity on some things. Java has also introduced in 21, but I think it's in preview, that you don't need to have classes. So those are hidden classes that you can script like if it was a Python file, but using Java, because there's an implicit Java when you are working. So this is also reducing verbosity and helping people to learn and enter the Java world. But I think we can do more in order to reduce verbosity in terms of that.
Okay, yeah. Thank you for thinking about that and telling us. And I would say let's move on to the next question, because we still got some.
Okay.
What would be the challenges of migrating from C++ to Java?
What would be the migrating of C++ to Java?
It was a very lively sound.
Yeah. I don't have experience with C++. I had experience with Go. Yeah, I know there are not equal, but I mean there are some. My experience moving from Java to Go that can or cannot be applied in this case to C++ because I haven't coded with C++, is that when you work with a language for a long time, in your brain, you use patterns to solve issues. So when you need to iterate a collection or a list of things, you have conventions in your language. So you directly go to that convention. It was a pain for me moving to Go in this case, because Go has different conventions. It's not that it is better or worse, it's that you need to adapt your way of thinking to those language conventions, idioms, and that's the hard part. In the end, every language has good things, bad things, and it all depends in the end in the developer that is using the language. But if the same developer moves from one language to another, The hard thing is the beginning, where you need to retrain your brain in order to use the new conventions. But I cannot say anything particularly with C++ because I haven't coded in that, sorry.
Yeah, no shame in that. Thank you for trying to give us answer. And I would say people can also Google things like that with the foundation they got from you. And so real quick, as we have 1 minute left, I would say as a last quick question, out of all these features you showed us, what's the best new feature in version 21 and why?
Well, I would say virtual threads is something very, very interesting. I mean, now you have, before that, concurrency was like a bit of magic and tricks because you were creating threads, but the system can only operate few of them. So it was like a false illusion that because you were doing concurrency, opening threads, things were going to be way faster than with not using concurrency. That was not the case. So you can improve, definitely, but at a certain point. Right. But with virtual threads, definitely it's a huge improvement because you can increase the performance a lot. Yeah, that would be my best feature.
All right. Jonathan, thank you so much for the informative talk. Also for the Q&A after. To the audience, if you still got some questions, he shared his socials with you. So I think he wouldn't mind at all if you sent those directly also to him.
Yes, definitely.
Jonathan, thank you so much for joining us today, and maybe we see each other on another live day.
Definitely. Thank you very much for the opportunity, and have a lovely day ahead for everyone.
Thank you. You too. Bye. All right. And before we jump to the second speaker of the day, 20-second break.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
And right back to Java and second speaker of the day. He is head of software engineering at Chrono24, has a PhD in software engineering, built his own consulting firm in which he helps fast-growing tech companies to scale their software development. Welcome, Jens.
Hello, it's a pleasure to be here. Thanks for having me.
Yeah, pleasure to have you, Jens. Thanks so much for joining. So I already told some things about you, but what I couldn't say to the audience is what your talk will be about and what we are going to learn from you today. Would you mind wrapping that up for us real quick?
Yeah, of course. So I will talk a bit about testing and probably a new way to think about how you could approach testing. Because as you said, like I'm in software development already for a couple of years, not as many as the previous speaker, obviously, but almost 20 years now. And I've seen very different ways to approach tests. And when I joined Chrono24, what I found there was really such a sophisticated and pragmatic way to deal with tests. It's basically the best I've ever seen. And like I'm with Chrono for 6 years now, and I really like that. And I think there are some ideas and new viewpoints that really could also help other people to have a better experience with testing, because testing sometimes is pretty mundane and painful.
Yeah, but nevertheless, it's one of the key disciplines when it comes to software development. So this is a very important topic to the audience. Listen to Jens, what he has to say. And Jens, I would say before I steal any more of your time, the stage is all yours.
Thanks a lot. So as we already said, okay, testing has been around for quite some time. And actually there's a rumor that I found in preparing for this talk is that the first version of JUnit was developed on a flight from Zurich to Atlanta to the Uppsala conference in 1997 Bikend back and Eric Gamma. So what else have two geeks to do on a flight, right? So that's actually like pretty interesting because it's around for more than 25 years now. And so you could expect that we pretty much know how to use or how to write good tests, how to use tests properly. And I think there are many, many good approaches and ideas out there, and you can find them. But so our day-to-day practice in many cases, in many companies, as far as I've seen, is not as good as it could be, and sometimes it's very painful. So, and as I said before, the things that I found when I joined Chrono24 that people started to build there and were created are really, really good, really pragmatic, very sophisticated. And that's what I want to share with you today. So what are the challenges we're actually facing when writing tests? And I prepared an example for you. And this example, so it's a bit scary, a bit daunting. So it's like the next slide will be just a wall of text. So please bear with me. And another thing, please don't read it. So I will walk you through it. So don't run away. So here it is. And again, please don't read it. So it's just like if I found this text as a developer and I like this one failed and I had to fix it, I would just, as soon as I see it, I would just go, oh, okay. So what does it do? What's its purpose? So this is just some wall of text and I have to walk through it and just to get to know it. So, and just to make it clear, this is just one single test method that just, in this case, tests the registration of a new user. So let's have a closer look at it. So the first part is basically the configuration of mocked objects. And yeah, it has two parts. The first thing is we want to sort of define what's the next user ID. The second one is like, okay, we define what's the next activation code generated. Then we have a call to our component under test. This is the method we're actually testing at this point. And it's the registration of the new user. Then comes a larger block, which is basically the verification of the results and the things that should have happened. And the first thing is we verify that a particular user has been saved and that that user has a certain set of properties. And in the second part, we verify that a certain email has been sent and that email has a certain set of properties. And here we see already like one of the first problems that we face with respect to unit testing or to testing in general. It's often quite a lot of boilerplate code that we have to deal with. And that basically means that if you look at a test, it's just hard to understand what's actually happening. And this is the one side of the coin. And the other side of the coin is if you have to write a test, it's also a lot of effort because you have to configure all the mocked objects. You really have to think about how do I get the stuff that I want to verify and what do I want to verify and so on and so on. So it's not so good. So the next thing that we have is something that is called the fragile test problem. What's that? So you can imagine that like a scenario, which might have happened to me at some point in my career, that you just have a minor change in your implementation. Say you move a method or some code from one class to another because it just, the scope wasn't right in the beginning. And just adjusting the tests for that, like that minor change, which probably takes you an hour or so, takes a disproportionate amount of time to get right. So like in this example, it shows just, it takes 2 days just to make the point here. And this is not good because it really slows you down. And the next thing is that these tests, if they're fragile, they also generate many false positives. And false positives are bad because they basically reduce the trust of your, of yourself, of your teammates and everyone working on the system in the test results. Because if all the results aren't useful all the time, so who cares about the tests? So that's a big problem. And another thing is that that's actually a problem, especially if you want to do test-driven development, that tests are running too long. And this is just the problem because it distracts you. So if you have to wait for your tests to complete long enough, then you will start something else. And this is like you lose your focus. You can't get into a flow. It's just some nice variant of a classical XKCD comic to make that point. So it just is a distraction in your workflow. So, and as a consequence of all of this, something could happen which is not good, and that is that, like, if you're in such a situation, no one really likes writing tests. And now you could say, okay, no one really likes writing tests. So what? I mean, it's a job. Not everything has to be fun, right? So just do it. Okay, but if really we are in a situation where writing tests is painful, that has consequences. So the consequence basically is, well, people tend to write fewer tests. Okay, what does that mean? Again, yeah, if people write fewer tests, you get lower code coverage. Okay, good. What happens? Like with a low code coverage, refactorings are becoming risky. So as a consequence of that, you're less likely to refactor your code. And if you're less likely to refactor your code, there's a good chance that technical debt piles up over time. And also, another thing, that if refactorings are risky, you probably need more time for manual testing, because there will be some situations where you say, okay, let's refactor this anyways, even so it's painful and we don't have the right tests and so on. So you need more manual testing. And that basically means you have less time for development of the things that actually bring your company forward. And if these two things come together, you basically you get slower and slower over time, and it won't happen in an instant. It's not a direct change, but at some point you will know that you are sort of too slow. And one contributing factor, of course, the only one, of course, this is a simplified view, but one of the factors that can contribute to this one is really a bad approach to testing. So let's turn things upside down a bit. So imagine we could have a system set up, a thing where we have tests that are actually useful, that are pretty simple to write and are also robust with respect to changes. So then I would assume that, at least me as a developer, I would like writing tests a bit more. So I would write more tests, especially if they're useful and help me to do my stuff better and faster. So I would do it. If we have more tests, we have a higher code coverage. If we have a higher code coverage, of course, we get more confidence in our refactorings. And this means that we can do more refactorings. And if we do more refactorings, and also we, like for the moment, we assume that we know that what we are doing will have a constant improvement of our code base. And another consequence is that, okay, if we have a higher confidence in our refactorings, we need less manual testing. And this basically means that we have more time for development and a good chance to increase the speed of our development process. Okay, so that was a bit about why should we think about testing and why should we probably think about find a way to make tests useful, simple, and robust. And this is what I'm going to talk about today. So I will walk you through a couple of steps to really address the issues that we had in the beginning, that we saw in the beginning. We will start with increasing the readability of the code that we saw. And it's just by getting the basics right. And then the next step will be to further reduce the boilerplate code by something that we call trainers and entity builders. And from there, we go and have a look at the fragile test problem. What's the cause of it? And how can we decouple the tests from our implementation so that in a perfect world, we can change both more or less independently. And then last but not least, we'll look into the question how to speed up tests that are slow and why tests are slow. And that's mainly because of dependencies, external dependencies, especially on the platform. Okay, then let's get started and have a look at the example from the beginning again. So we want to increase readability. And if you read into the literature and looked at things, what's out there, you will at some point find this given, when, then pattern, or sometimes it's like the first, like you have always these steps, like given like the setup of the system. So like we already defined it a bit, you always have the call of the component and the test, which is the when, and then is the verification. You will always find these three steps. Sometimes there's still also a tear down step. And we pretty much like the concept of this given, when, then, which comes from behavior-driven development, and it's also used in Cucumber. And I know that I think Martin Fowler is also an advocate of this. So it's pretty useful, and we would like to do as a first step, we would extract some methods here and by applying this given, when, then pattern. So if we do that, the result. So first of all, we see, okay, the configuration obviously is the given part. The registry, like the calling of the component and test, obviously is the when part, and the then part is the verification. And if we do that, the code instantly becomes much more readable, so much shorter, much clearer. So we see we have a given part here, where the next user ID is specified, where the next activation code is specified, that we see, okay, up here's the call, something happening with the registration of the user, and then a new user is created with some properties, an email is sent with some properties. So that already helps a lot. And at Cron 24, we have a simple convention, so we don't add comments for the given, when, then section. We don't use annotations or anything. We just use a prefix to make it clear what we're dealing with here. And so that at least helps us quite a lot. So now, this is already an improvement, but still there's a problem, because I can't really see immediately what's, for instance, the relationship between the activation code and the email and the user. So has it any relevance? And of course, if I go through the code, I see, okay, it's used here and somehow here in the URL. But what we want to do is we want to specify an explicit relationship between the given part, so the specification, and the result, so the verification part. And to do that, we just, it's also simple refactoring of the code. We will introduce some constants. So now I can, and also say like, okay, if we have a derived value that's basically derived from the input, then we make clear how the input relates to the result. And then I can, in my favorite IDE, I can basically directly see where the activation code pops up again in the result and what the dependency is. And now the test is already much clearer. And so we can say, well, just getting the basics right gets us very far. So it's now pretty readable and you know what's happening. So we're done for now, right? Thank you for your attention. It was a pleasure. Of course not. And the reason is that we still, if you look at our test class as a whole, it's still a mess. It's just, this is our test. This is the code I've shown you before. And all the rest is just boilerplate that we need to, well, make this single test nice and readable and running as well. So we still have a bit of work to do. And another thing is that we also would like, of course, to reuse the given and then methods for other test cases. So if we have another test class where we use the user repository and need to configure the mock objects, it would be really nice to reuse the methods that we just created. So that would be our next step. So how can we reduce this boilerplate code? And the idea that I would like to show you are entity builders and trainers. So let's start with the entity builders. I would assume that you have a rough idea at least what a builder is. But just let's start with the basics here. So so usually if you have a test and you need an entity, you sort of need to configure the attributes with the values that you need for your test case. So in this case, the user, you set an ID, an email, a name, activation code, and whatever. But it's a lot of detail, and it's not really clear why you need it here. And it's a lot of noise in your test. So the first thing is to use a builder pattern here, which makes things already a lot simpler. In our case, we use the JUseCase builders generator, which is actually an open source project of one of our developers here. And that provides us with a fluent syntax. So we can basically say, okay, we want a user, and that is a user with ID, with email, and so on. But still, it's a bit more readable. It's nicer, definitely. But it doesn't tell us why we need these attributes and what's the connection here to our test. So the next step is, usually in your entities, you have a set of basic attributes that you just need for the tests to run successfully, but which are not really relevant for your current test case. So the entity has to have an ID, a user has to have an email, and so on and so on. So basically, this can be encapsulated in a single method. And this makes the construction of this entity for your test already a bit clearer. So you now see, okay, I've got a user with basic attributes, whatever that is. And obviously for this test, we need an activation code, and the property active has to be set to false. But so this is a lot of detail, and maybe it's cleverer to say something like this, to say, okay, we want a user that is in a particular state, which is activation is required at this point. So now I'm not talking about the details, but I have a nice abstraction level that basically just tells me I have a user with basic attributes in the state activation required. And from there on, I can build my test case. And we have a convention in 2024 to make this even simpler, where we just say, okay, the initial creation of the user object or any entity is always it's always filled, or the basic attributes are always set there. So you create a user, it already has a name, it has an email, and blah, 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 all the things that you need. And then you basically pick the state where you want the user to be in. And from there, you can move on with your configuration of the object that you need, of the entity that you need. So this is really helps us to get from this low level, I've got all the details in the test case, to a really nice level of abstraction where you see, okay, basically for this test, I need a user in the state activation required. Okay. Now let's talk a bit about the concept of trainers. And let's first have a look at the problem that we're trying to solve here. So this is again the example from the beginning, and the problem that we're facing here is that the configuration of mocked objects is very repetitive and also very verbose. So if you just look at this example. More than half of the code that you have is just mocking things. And it's just a distraction here. And the idea that we would like to establish here is basically say, okay, let's introduce a class that's specifically designed to configure one mocked object. So, and these classes, let's call these classes trainers. So we basically encapsulate the concern of configuring a specific mocked object in a trainer. So here's an example. So we have the user repository in our case. We can create a user repository trainer, and that trainer gets the given and then methods that we previously had in our test class. So it's fairly simple. So you got the trainer object. It contains the mocked object, of course, and the given and then methods are given next ID, given entity exists, then new user is created, then user is updated, then no user is updated. And if you now do this for a couple of repositories over time, you will realize that it's very similar for most of the cases. So what you can do is you can create a generic CRUD repository trainer that basically here does the same thing as the user repository trainer in our case. It just has a generic mock. You can specify the next ID, given entity exists, and it's always entity here, not user or something. So then new entity is created, then entity is updated, or then no entity is updated. And this would allow us to also simplify our implementation of the user repository trainer, because we could just extend the CRUD repository trainer, configure it basically, give it the right types here, and just create an instance of the mock class, and that will be it. So what's the benefits now of trainers? So we push the configuration of mocked objects outside of our test class, and this allows us to make not only the test class more readable in the ideal case, but also all the mocking configuration, because it's just the concern there. And we can also reuse the trainer in different tests for different tests that we would like to write. And we can also move, make an additional move and create generic trainers that actually help us to further simplify the test setup. So both concepts, entity builders and trainers, simplify the setup of the test fixture. So that makes life already a lot easier. Now, that part is solved. Now, let's look at the fragile test problem. So first of all, I would like to discuss a bit about, or show you what it actually is and what it means and why it's a problem. So imagine you've got an implementation on your left-hand side and a set of tests on the right-hand side. And we stick with our example here. We have a user service, and that is tested by a user service test. And the user service test has mocked configuration, a mocked object of the user repository. And now, over time, you continue your development, things get more complicated, the user service grows. And at some point, you decide, well, let's split it up. So we see these three services, they all make sense. We keep the user service as a facade. This is really nice. And yeah, but what about the test? So you did your restructuring, your refactoring. What about the test? Okay, let's we have this user service here, and we have a user service test, so it should only test the user service. We create mock configurations, or we mocked objects for all the other services that we added. And now our test is already nice and green again. But we're not done, unfortunately, because now this test, well, tests way less because we moved a lot of the logic to our new services. So we need to write 3 new tests, 1 for each new service. And then we have to think a lot about, how do we replicate the same testing behavior that we had before in these tests? Well, either definitely to do that, we need a more configuration of the user repository, and we do that, and then we're done, and everything's fine, right? So that's exactly what we wanted. Well, of course not, because there are several issues with that. First of all, even though from the things, from the code changes you made, this could have been a refactoring, it is not. And why is that? The refactoring is defined as a sequence of small changes that keep tests passing at all times. And that was not the case. So we had, during the process, some failing tests in between. So that was not a refactoring. Why is this an issue? So, I mean, okay, it's not a refactoring. What's the problem? Yeah. If you think about it, you basically now have 4 completely new tests. So the initial test had to be split up, and since we have all this mocking going around here, we also had to split the test logic into several parts. So you can't be sure that what you're testing now is exactly the same thing as you've been testing before. You can't, you don't know. And this can lead to, potentially, to chaos and insecurity, since bugs aren't easily found during development. Another example, so if you now, it's like a few months later, you decide, okay, probably this user notification service was a pretty bad idea. We didn't know that at the time. It looked good, but it's not. We want to refactor again. And probably you would say, okay, we now need a user activation service, and a part of the logic here would go to the, I don't know, user profile service, whatever. If you do that, all these tests, even though if you just move code here, all these tests will break. And you would have to change the test again. And again, you wouldn't know if what you test afterwards is the same as you test before. So you don't know if you change your system behavior. So that's not good, again. And this leads me to the next point. So because every time you change something here in your implementation, you have to change something in the tests. And if we zoom out and just say, okay, we're not talking about implementation and test, we talk about, say, a component A and a component B, you would definitely say, if you look at this graph, these are really tightly coupled, right? So every time, every item on the right-hand side is connected to something on the left-hand side. And whenever I change something in component A, I most likely will have to change something in component B. So that's a problem. Yeah. So you could say it's tight coupling. Tight coupling is bad design. It's bad design. You shouldn't do that. So what's the solution here? Well, the solution is actually fairly simple. You don't do tight coupling. You just create loosely coupled tests. So when you decide to do your refactoring here, you just say, okay, the service test, the user service test will continue to test the whole thing, and we'll keep it that way. So, and if you keep it like this, you just say, okay, we test the whole thing and all these implementations in here. Also in later stages, if you decide, well, the user notification was a pretty bad idea, you can refactor without having to adjust the tests. The only thing you might have to do is to tell it, well, these are now, these are not going to be marked or whatever. So that's the idea. very simple. And it actually allows you to do a nice thing, because now you can structure your tests independently from your implementation. For instance, in our case, we use use case tests, and we define use case. So could you say, if the user service grows, the user service test most likely will also grow. And at some point it will be too large, and you would think about how to split it in a good way, presumably, to split it can be to go for separate use cases. So you can create a test just for user registration, register user test. And you can test the Happe path there, or the shit cases, or the edge cases. So you have that in one test class, and then you go for another and another and another, and that can be independently of the system. I know that this topic sometimes raises a bit of emotion. People are like, just, well, wait. You can't do that. That breaks the rules. What rules? Yeah. For every class X, there should be a test class X test. That's not a rule, actually. So no one of the founders of test-driven development ever said something like this. And it might be written somewhere, but just because it's written somewhere, it's not a rule. And also, even if it were a rule, it wouldn't be useful. Like, as we've seen before, you run like lots of problems there. So that's, even if it were a rule, it would be a stupid rule. So no, that's not the case. That doesn't have to be the case here. Now we could argue and say, well, that's indirect testing. So okay, what's indirect testing? So it's basically saying, okay, you test something via something else. So a typical example is you test your application code through the presentation layer. And that's obviously a bad idea, because as soon as the layout of your presentation changes, the test breaks, even though the behavior of the application itself is correct. So you don't want to test through the application layer. And it's typically done when when you don't have access to the system internals. So, but we have access here, and we can test through the user service. And of course, it could be indirect testing. So, what's the negative consequence of indirect testing? So basically, the test setup will be very complex, and you just need a lot of additional entities that need to be configured, additional mocked objects that need to be configured just to run the test. And the test that you have basically just tests a part of it. That will be indirect testing, and that's to be avoided for sure. But in general, we could say that usually we're testing too detailed. Having a bit of a broader scope makes absolute sense. And it really depends for the registration workflow here. In this case, you could have something happening in the user profile, something happening in the notification service, like sending out an email or something like that. So it rather depends. Yeah. And it depends on whether it's useful or not, basically. All right. Another thing, you say, okay, obviously now, again, this is more code because it's more classes, right? And if it's more code, then it's harder to identify the root cause of a failing test. No, because ideally, you should work in small increments and run tests after every change. So that would be good. And if you don't do that, of course, if you do that, it makes it pretty easy to identify the cause of the failing test, because it's somewhere in your small increment that you just tested or just wrote. If you don't do that, of course, if you work for 6 weeks and then you run your tests, then of course it might be pretty hard to identify the failing test, but that is not the fault of this test setup. The cause is that you don't run your tests often. Okay. So basically, saying what I'm trying to say here is tests should be useful. So we should design them that way. So we have really to take care not to be too dogmatic in one way or another. We really have to look at, okay, what's useful in our case, in our scenario. And it can be useful to sort of have broader, have tests that probably test more and not every unit just by itself. All right, let's move on and talk a bit about how to speed up slow tests. And first of all, we have to think about why tests are slow. Because they're not, like, if you run just plain Java tests, they're incredibly fast. And what slows down our test execution is, in generally, all of our external dependencies. So that is the database, the framework that, like the middleware that provides everything your services are running in. Then the delivery mechanism that you have, which is usually the web, right? All these things slow down test execution. And yeah, that's a problem. Yeah. And if you need any parts of these for your tests to run, excuse me. All right, what to do about it? The idea is basically to say, let's push all external dependencies as far aside as we can and only focus on the logic that we can test. And this is, of course, it's nothing new. You've probably heard that before. It's called clean architecture, hexagonal architecture, whatever. That's the idea. So on the outside, you have very concrete things like specific database, some external interfaces, your UI, the web, some devices, whatever. And the more you go inside, the more abstract things get. And there's another rule for this kind of architecture, is basically saying only the outer circles can know things about the inner circles. The inner circles don't know anything about the outer circles. So that's the dependency rule. And if your system is designed like this, it's intrinsically testable. This is nice, of course, but reality is messy. So your software, like if a software system evolved over decades, it most likely doesn't have a clean architecture, at least not everywhere. So we somewhat have to deal with these external dependencies that we have. And how do we do it? So actually, we talked already a bit about it, what can be done. So one thing is here on the repository side, the concept of trainers and repository trainers already helps a lot, because we can get rid of the whole repository implementation, the database, so we don't need an H2 or anything. We just have our trainers there. And that's what we also did. So we tried to reduce the external dependencies as much as possible. And if we need something, we just make it as lightweight as we can. And so we have a sort of lightweight dependency injection, which is really fast. We have the builders and trainers. And well, here, unfortunately, we still have real requests and responses, but this could be also improved. So, and just to, okay, the number will follow on one of the next slides. So our tests are running pretty fast. I'll show you soon. So, but don't be afraid of tests. Don't be afraid of tests. They are actually not as bad, pretty useful. And in the next slide, I would just talk a bit about our journey at Chrono24, so that you know also, like, okay, we didn't start there. Obviously, we had to also find our way to like how we write tests and how we work with them. So in the very beginning, there were basically almost no automated tests, and only in 2016, the ideas of test-driven development started to come into the company, especially through new hires, and people said, okay, we need something like this. And then the concept of like entity, like, okay, but we don't want to create the mess that comes with all the mock and stuff. So the concept of entity builders and trainers were developed, and we established the idea that we want more like approach tests by looking at use cases rather than units, just testing individual classes. And this was basically the foundation. And from there, we continuously improved. We moved from Jenkins to GitLab CI, which basically helped us to run tests with every push. We moved to a mono repository with parallel build that sped up things quite a lot. And just to give you a number, is today we have about 12,000, just a few missing, use case / unit tests that run in less than a minute. And we had quite a discussion if it's a minute or how long it is, because on an M2 MacBook, it's actually 44 seconds. So that's really nice. So what are our key takeaways for today? So first thing we did is getting the basics right and applying this given when then pattern gives already a lot of structure to your tests. And then making relationships between pre and post conditions is also something that really increases readability. So that's already pretty nice. Then we need to do something, or we did something to make the definition of scenarios, like your setup of your test fixture, simpler, not so painful. And the two things there are basically the entity builders with the conventions that go along with it, and the trainers that really simplify the configuration of external dependencies for the test. So from there, we go to we get a reusable and simple test set. Then we talked about the fragile test problem and thought about how can we decouple test and implementation. And the idea there is we try to test at the borders of what matters at this point. So it's not dogmatic in any sense, but you have to figure out what's useful for you. And that allows you then, if you do that right, to structure tests and implementation independently. And last but not least, I just gave you a bit of an idea how to separate, like how the separation of tests from any external dependencies can help you to speed up test execution. And the idea there is simply by remove and simplify supporting frameworks dependencies as much as you can to run tests. That was all. Thank you very much for listening. And of course, many people contributed to this work, especially to mention Andreas. So he's the mastermind behind all these ideas and testing concepts. Of course, if you want to really dig into the details and know everything about it, there's a simple way. You can just join us. And if you just want to get in touch, drop me an email, contact me on Twitter, or just on LinkedIn. Thanks a lot. And then I would hand back to Bene.
Jens, hello again.
Hey.
Awesome talk. Thank you so much for providing all of this info about testing for us. It was really informative, but there are still some open questions from the audience. Mm-hmm. And I would say, as we have some minutes left, let's tackle them. And the first question is a pretty simple one because the audience wants to have your slides. Would it maybe be possible for you to provide them via your socials in some way?
Yeah, I will.
All right, perfect. Then first one marked. Let's go on to the other questions. And the first really technical question would be, what would you say? What would you say were the most common challenges with integrating? What would you say the most common challenges with integration testings are?
The most common challenges with integration tests. they have a couple of challenges. I mean, if you have an integration test, you obviously have to do something which I just tried to tell you to avoid, which is you have to get your like external dependencies somewhere pre-configured. So and you also need to start them, to run them. So that's an issue because it has several consequences. So it basically means your tests will be slower, because like if you have even if it's just an H2 database, which is in memory, it takes some time to ramp up. You have to probably, if you don't want to ramp up for each test, you have to think about the tear down again. You have to, yeah, and you really like integration tests. It's heavy. Like if you really want to have the existing things there, it's heavier, it's slower, and it's not fit for a classical TDD workflow. So I would always minimize the number of integration tests as much as possible. So just to give you an example, at Kotlin 24, we have 12,000 of these use case tests, which run in less than a minute. We have about 1,000 integration tests that run in 3 minutes, and just around, like, I don't know the exact number for the web tests. It's below 100 and more than 10, something like this. And it's they run in 6 minutes. So you see, it gets slower as higher as you get in there. So and speed matters.
Okay. Yep. Makes totally sense, at least to me. Thanks for answering this question, Jens. Let's move on to the next one. Does extracting methods make things less clear for new readers, as they now need to index through many different methods? How should we handle a lot of methods coming out of this approach?
Yes and no. So like for the first question, like if it makes things more difficult. So I think if you do, like it's the classical argument for like what level of abstraction should a piece of code be on. So if you provide too many details and it gets too long, it's hard to understand because you have to read everything and make the abstraction by yourself. Of course, if you group things and have a higher abstraction, you lose all the details. So that's the problem there. So my personal opinion there is to say, okay, if I read a test and I have a good convention of structuring my tests and extracting the methods, then I would rather prefer a higher level of abstraction, because I can easily understand what all these things are about, and then I can drill down in the methods where I see the problem or where I need the details for whatever reason. So I don't know if that answers the first part of the question, but I hope so. And then the idea is not to have like any kind of like extract any methods, whatever you like, but you have a bit of a concept. You have this given when then, so there's already a pattern. And you also start with the trainers. You move the configuration of mock object out of your test class. And if you have a good convention, then you already know, you see this, okay, this is a repository trainer. You already know what it does. You see, okay, given entity exists, you basically know what it does. You don't need the details to understand what's happening there. I hope this answers the question.
Yeah, thanks for that, Jens. Let's move on to the next one. Mm-hmm. Going from a test per class to a test per use case is quite a change. Mm-hmm. How would you bring it up with your dev team?
Always start slow, right? So I think it's very important that people understand the problem. So if the problem is not there, so if you don't have a problem of fragile tests and everything's good, you would have a tough time convincing people to change something. So, but if the problem is there and you have fragile tests, you most likely will have people on your team who are open to try new things. And then you would probably work with these people and just say, hey, come on, I heard about this approach. Let's try it for sort of a specific set of tests. And you work with these people and these tests and see how it goes for you. And of course, it won't be perfect in the beginning, and you have to learn your things and how it's done best in your context. But once you have a good understanding, and also you've got the feeling that the people who are working with it are happy with the results, you can actually start spreading it in your company and your teams. So that's the way I would do it.
Thanks for also sharing this with us. And let's move on to the next one. Do you think Cucumber framework could make the tests more readable?
I must honestly say that I never worked a lot with Cucumber, so I can't really tell you if it's in the end it's an improvement or not. But for our case, I would say we have this convention of naming methods following the Gherkin syntax. So that already allows us to talk about the use case that we have about the pre and post conditions with our product owners / product managers. So we can talk on that level. And so I'm not sure if in our case now Cucumber would add an additional benefit. But of course, it might be worth a try. So sorry, I can't give you a definite answer here.
You can't know everything, Jens, and you already know a lot. So it's totally fine. And yeah, maybe people can also check other resources. And we go on to the next question. Maybe I didn't get it right. Did you say indirect testing is okay?
No. Well, indirect testing is definitely an anti-pattern. So if you test through your presentation, basically you compare. So you have some template that's rendered, and you compare the output of the render template to an expected value. Then it's of course a stupid idea, because as soon as something changes in the template, your test will fail. But the thing is, indirect testing becomes an anti-pattern at the moment you're building up concrete. You have to build up everything. You have a complete test setup just to test a subclass somewhere inside your structure. That's indirect testing, right? But and that's not okay. That's not a good idea. But if you just have, in our example, there was the user service, and it also has interaction with several services below, and you test that whole thing, it makes totally sense. So it's not indirect testing. Yeah, just to make that clear. Yeah.
Okay, thank you so much for clarifying that as well. And we move on to the next question. Do you think testing is a good entry job for a developer coming from a university?
Depends on what you want to do. And I don't know if so testing can be various things. If you mean writing tests, then I would. So if there's a company where there would be a job offer saying, we're looking for someone who only writes tests, I would really ask why. Because I think writing tests should be part of the development process. So that would be some indication that in that company, probably something's not as I would like it to have. No, I won't say wrong. So I would question that. So if that means that you say, okay, you work in a team where you provide some infrastructure for the team so that they have a better time writing tests, then probably yes. And if you mean just testing in the sense of I'm just clicking through things, I would also not do it. So it also really depends on what you want to do and where you want to go. If you want to become a good developer, it never hurts to write tests. Yeah, but I wouldn't specifically suggest applying for a role where you only do testing, because I believe that's not a company where I would like to work.
All right. Thanks also for that. And yeah, we have time for one more question. And let's tackle this one. How much more efficient is it to test with your framework? Do you have something like a benchmark comparing to traditional attempts?
No, I don't have it. I'm sorry. So, as I said, in our journey, we basically, when we started, we already were pretty aware of all the problems that you could have if you have too complex tests, and if you have too many external dependencies and so on. So we all the time worked hard on getting this as fast as possible and good as possible. It's not like this was our initial state, it was really bad, and now we're here and it's really good. We just know we don't want to go there, but we started somewhere here, and we tried always to be on that side. So I'm sorry.
I mean, I understand that people always love benchmarks and numbers, rising numbers, that is. But I think you convinced lots of people with your presentation today about your framework. So thank you so much for sharing all of this with us, Jens, and also for the Q&A. And hopefully we see each other on another live day.
Yeah, I hope so too. It was a pleasure. And to all of you, have a great time here at the Java Developer Day.
Thanks, Jens. See ya. Bye.
Bye.
All right. And before we go on to the next speaker of the day, a short 20-second break.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
And right back to Java and the next speaker of the day. He is Senior Java Developer at Team Rockstars, and he loves to share his knowledge through his work, blogs, and by giving talks such as today. Welcome, David. Hello, David. You're muted.
Muted. Not anymore.
Much
Thank
better.
you for having me. Love to be here.
Yeah, thanks for joining. Before we start, would you mind telling us a bit about your topic of today?
Yeah, of course. So today I'm going to talk about virtual threads, which is one of the most anticipated features of Java 21, which will be released in just a few days. So I'm really excited for this new feature, and I hope all of you are as well.
So perfect timing to get started with the new features of version 21. And I would say, David, before I steal any more of your time, stage is all yours.
Oh, thank you very much. So today I'm going to give you all an introduction and tell you all about the pitfalls of Java's new concurrency model. Well, as you all know, my name is David, and we have a lot to talk about today, so let's get started. So what I want to start with is the current situation. What is the current way of threading that we have inside Java? How do we use it? What are some of the limitations that we encounter? And then slowly, as we will see, there is lots to be improved on in some use cases. Then I will start talking about virtual threads, how they fit those use cases. And of course, how you can create a lot of threads, because that's what they are really famous for. And that's really awesome to show. But when you have a lot of threads, you want to somehow manage those lifetimes of those threads. And that's where structured concurrency comes in. And we will dive in what it is and how it works and how you can use it yourself. And then at the end, there's some time for a Q&A. So a little disclaimer before we really start. Some of the things are still in work in progress. For example, the virtual threads, the API, it's stable, it's ready to use. But of course, there are always little bugs that, still need solving. But the API is stable and it's really ready for professional use in production. But the structured concurrency part, that is still very much in development. So the API may still change, but the ideas behind them will be the same. So please keep that in mind. And of course, it's targeted for Java 21, which will release the 19th of September. So we only have 6 days left, and then we can finally start using it in production, which is really great. So let's get started. So this is the current way of threads that we currently have inside Java. We have the thread class. And the example here, I think all of us are familiar with it, is that we create a thread using the thread class. We call the constructor. We pass it some task. And what happens behind the scenes is that when we call the thread constructor, we make a call to the operating system. When we ask the operating system, can you create a thread for us that we can use inside our application? And the operating will do so. And while doing it, it will reserve some memory, around a megabyte each, depending on your operating system. And doing and making this call to the operating system also takes some time. So combining these two things, that it takes some time, and the biggest thing is that it uses up a lot of memory. We find these kinds of threads to be very resource intensive because they use a lot of, especially memory. And because they use up a lot of memory, we can't have a lot of them, as you will see later in the presentation. But with these kinds of threads, well, currently on my laptop, it stops at around 10,000 threads. If I create more, then it will just give an out-of-memory exception. So that's why we find these threads to be very an expensive resource, and you have to be very careful with creating too many of them. And well, when we created this thread, we can just call start on it, and we'll start running the task that we gave it. And as you can see at the top of the screen, I call them platform threads. And we call these kinds of threads platform threads because we want a way to tell the difference between the new virtual threads and the old threads, the new platform threads. And they are called platform threads because they are managed and scheduled by the operating system. So that's why we call them the platform threads. So how can we use these kinds of threads? The easiest way for us developers would be to create a thread for every task that we have. So here I have 3 tasks, and for every task that I have, I will create a single thread for the task to run. While this is a very easy way for us developers to use these kinds of threads, we don't make the best use of the resources that are available to us. Because for every task that I have to go to the operating system, I have to reserve some memory, and the thread will just be discarded when it's done. While I could, for example, reuse them, which would be better. And there is the danger that I have when I get too many tasks, I will create too many threads for my system, and I will get an out-of-memory exception. So while this is a very easy way for us to develop our applications, we don't make the best use of our resources. So what can we do to improve on this? And one of the things that, well, since Java 5, we are encouraged to use the executor services. So here on the right, I have my little pool of threads that I can submit tasks to. And this is a very convenient way for us because every time I have a task, I can just submit it to this pool of threads. And when a thread is available, it will pick up a task, it will execute it. And when the task is done, the thread will be put back inside the pool and it will pick up another task. So we now pool our threads so we can reuse them, which is really great. But there are also some things that you have to watch out for. For example, if you have a task that sets a thread local variable, and this task forgets to unset this thread local variable, then this thread will be put back inside the pool and with the old thread local variable. And other tasks that run on this same thread are able to read those thread local variables, which isn't really nice. And at that point, you are leaking your thread local variables into other tasks. And of course, there is the case that if you have a thread that is waiting for example on a database call to return a result, those very precious platform threads, those threads inside that executor, inside that pool, they are blocked. They aren't doing anything. They are just waiting, which is really a waste because they could do much better things instead of just waiting for a database to return something. So one way to improve on that is using, for example, async programming. But in my opinion, async programming is very hard to write because it affects your whole application. It's harder to read, especially 2 weeks after you wrote it. And it is hard to debug because Java is built around threads and frames, which async doesn't directly use, which makes it kind of difficult to debug. And that's where virtual threads come in. They are another solution to the problem, and they are an alternative implementation of the thread class. So the old platform threads that aren't going anywhere, but we just get a new flavor of threads that we can use inside our application. And the best thing about these virtual threads is that the operating system doesn't know anything about them, which is really great. So they are just a concept that lives inside the JVM. And the benefit of that is that when we create a virtual thread, we don't have to go to the operating system. It doesn't have to allocate a lot of memory for us, but we can just do it inside our application. So when I create a virtual thread, I can just allocate a little tiny amount of memory in the heap for my virtual thread to use. And as my virtual thread grows, its memory usage also grows. And then I can just allocate more memory in the heap. And when it uses less memory, I can just allocate a little bit less memory for it in the heap. So now it's stack frames of this virtual thread. It can grow, it can shrink, it can grow. So it's resizable, which is a really big benefit. So when I create my first virtual thread, I only have to reserve a tiny amount of memory. And because they use a very small amount of memory, we consider them very cheap to create, which is really good, which is really great benefit. So this enables me to do the first programming model in that I create a virtual thread for each task that I have. So this is a very convenient way to develop your application, but it also makes good use of the resources. So I built this. I built two applications. One of them uses the platform threads, and one of them uses the virtual threads. And what I wanted to show you was the difference you have in memory usage when you use one kind of threads or the other. And as you can see in this chart, is that if you are using between 1 and 100 platform threads or virtual threads, there isn't that much of a difference in memory usage because it's very close to, they are very close to each other. At 100 threads, you can see that the platform threads start using a tiny bit amount more memory, but that shouldn't be the reason why you start rewriting your entire application. So if you're just using a small number of threads, I would recommend you still use the old platform threads because it doesn't really make that much of an impact on the memory usage. But when we start to use more threads, 1,000, 10,000, or even 100,000, you can see that the platform threads and the memory usage really start to take off. At 1,000, it almost doubles, and at 10,000, it really skyrocketed to more than 450 megabytes of memory, which is really a lot if you compare it to the virtual threads, which almost didn't seem to change. And that brings us to the last bar, the 100,000. And this is really the most amazing part about virtual threads, is that you really can create all the virtual threads that you need. You can create 100,000 of them. It isn't a problem. Your application will start using a bit more memory, but it's all should be fine. While with the platform threads, I ended up with an out of memory exception. So that's why there is no blue bar at the 100,000. So that's enough of the slide. So let me show you some code. So as I've said, the virtual threads are just an alternative implementation. So I can still use a thread instance to store my virtual thread. And to create a virtual thread, we're not going to call the thread constructor, but we're going to use the start virtual thread builder method. This static builder method will create a virtual thread for us and will also immediately start it, as the name does suggest. And I'm going to give it the print task. And I'm going to call VT to join to give the virtual thread a chance to print something to the console. So when I run this example, it prints hello everyone to the console. So you now have been officially greeted by a virtual thread, which is really cool. So with Java 21, you can create a virtual thread with just a single line of code. And if you wanted to print something to the console in time, you have to also call join, but I don't count that one. So with just one line, you can create a virtual thread, which is really cool. But that's not all. With Java 21, we also get a builder method that we can access using the off-virtual. The off-virtual will create a virtual thread, while the off-platform will, of course, create a platform thread. So let's choose the off-virtual, and then I can set some properties, like, for example, the name. And I can give it a unstarted task. And a unstarted task will just create a virtual thread, but it isn't started yet. So I have to call the start method myself using start. And when I rerun this example, it again prints hello everyone to the console. Well, that is all very nice and clear. So we get this new builder, but since Java 5, we are encouraged to use the executor services instead of the thread class directly. So with Java 21, we also get a new executor service. So that's the one I'm going to create now. And it is called the new virtual thread per task executor. Oh, and as the name does suggest, it will create a new virtual thread for each task that is submitted. And as you can see, IntelliJ already gives me a hint or something I can improve. And that's very true, because since Java 21, or 19 to be precise, the executor service implements the auto-closable interface. So now I can use them inside the try with resource statement. So I don't have to close my executor service, but it will be done by the application itself. So now I can just submit tasks, the print task, 3 times, and I run it. And as you can see, it prints hello everyone to the console 3 times. So the great thing about this is that I don't have to call join on these virtual threads. They will be automatically started. I don't have to call join. And the great thing is that when I exit this try, I will know that my virtual threads are done. They will either have finished successfully or they may have failed. But when I exit this try, I will know that my virtual threads are done one way or another, which is really great. So I promised to create a lot of virtual threads in the beginning, so let's do that right now. So I will create 10,000 virtual threads using a for loop. I will use the sleep 1 second task, which will make the virtual threads sleep for 1 second, and then they will wake up and continue. And while this isn't really a business case, nobody creates a 10,000 threads to just let them sleep, But what I want to show you is that with just on a simple laptop, you can create 10,000 virtual threads without your application running into a out-of-memory exception. And as you can see, it ran successfully. Just took a little bit more than 2 seconds for the whole process to run. But I am able to create 10,000 threads on a virtual 10,000 threads on a laptop, which is really great. But, well, as I've said, it's just a laptop. So how do these 10,000 virtual threads actually run? So you kind of get into this situation that you have the 10,000 virtual threads, but, well, this system, it has only 8 cores. So how does this actually run? So here in this slide, I created a bunch of virtual threads at the top. And these virtual threads, they run on what is called a carrier thread. And a carrier thread is nothing more than just a platform thread that is designed to run these virtual threads. And you will get as many carrier threads as that you have cores available inside your system by default. So if you have a 4-core system, you will get 4 carrier threads. If you have an 8-core system, you will get 8 carrier threads. And these carrier threads will run the tasks inside your virtual threads. So let's dive in a little bit deeper. So these carrier threads, they run inside a fork join pool. And when you create a virtual thread, you submit them to a queue. And these carrier threads, they will pick up a virtual thread from this queue, and they will start running it. And every virtual thread that you create will end up inside this pool, and these carrier threads will execute it. So how does a virtual thread or a carrier thread know when to switch from one virtual thread to another? And that is done through mounting and unmounting. So here I have a carrier thread that is running a virtual thread on top of it. And this carrier thread will continue running this virtual thread until it encounters a blocking method. And when this virtual thread encounters a blocking method, it will be unmounted. So it will be, its stack from this virtual thread will be copied from the carrier thread back inside the heap. And a new virtual thread will take its place. So the old virtual thread that is blocked will be unmounted. So its stack will be copied from the carrier thread back inside the heap. And the new virtual thread will take its place. It is being mounted. And those stack frames will be copied into the carrier thread. And the great thing about this is that now the old virtual thread that is blocked will be blocked inside the heap, so it isn't harming anything. And the carrier thread, which is the very expensive platform thread, is always doing something. It is now running this new virtual thread, so it is always doing some work instead of waiting, which is a really great improvement. But not every method is ready yet. So not every blocking method is ready to be used with virtual thread. For example, a synchronized block, a object.wait, or when you make a call to native code using JNI. And even certain file operations may cause your virtual thread to be pinned to the carrier thread. And what it means is that it can't be taken off of the carrier thread. And then your carrier thread is blocked, which we try to avoid using the virtual threading. But when you use one of these 4 methods, your virtual thread will be pinned, which can have an impact on the scalability of virtual threads. And a small remark on the synchronized block. You don't have to start rewriting every synchronized block inside your code. But if you are in a synchronized block for a very long time or very often, only in those 2 cases, it could be worth it to check if it would be better to rewrite it using a lock. But if you're just for a very small amount of time inside a synchronized block, it's all fine. or when you are inside synchronized block, not very often. So you don't have to start rewriting your code immediately. And to see if a virtual thread is pinned, there are these two options that you can use: the run option, trace pin threads, or the system property. And then the application will print to the console when a virtual thread is being pinned. There are two types. You have a short description. We will just show you where inside your code the virtual thread is pinned. And you have a longer version, which will give you some more insight. But the short version should suffice for most use cases. So when you use one of these options, you will see when a virtual thread is being pinned. So the pitfalls of virtual threads are that they are not faster than the current threads that we have. They are maybe even a little bit slower because of all the overhead. But these virtual threads, they just run on these carrier threads, which are just the normal platform threads. So just by switching from the platform threads to virtual threads, you may not see an immediately improvement in performance, because they are not any faster. You can just have a lot more of them, a lot more virtual threads. Then there is that you don't want to use virtual threads for very long-running calculations, because these virtual threads, they are meant to block. They are very good at waiting, just being blocked. So when you use them for long-running calculations, those virtual threads, they will never block, and they will just be stuck on these carrier threads. And then for those use cases, it would be better to use the old platform threads instead of the virtual threads, because there is no difference at that point. Then, of course, because these virtual threads are this cheap to create, you don't want to pool those virtual threads. Pooling is a very big no-no when using virtual threads. So because they are so cheap, we have to start thinking of these virtual threads more as tasks that we want to run. So if I have 10,000 tasks that I want to run, I will just create 10,000 virtual threads, one for each of those tasks, instead of pooling them or something in that matter. Because these virtual threads are just meant to be created when you need to and to be discarded when you are done with them. And of course, you have to watch out with all the libraries that may not have adapted to virtual threads yet, because they could use these unsupported blocking methods. So this brings us to structured concurrency, because now we have these virtual threads. We can create a lot of them. And now we need one way to manage all those lifetimes of these threads. And before I dive deep into what structured concurrency is, I want to start with a very simple example, and we will work our way down from there. And that's with structured code. And the great thing about structured code is that this method, it's a simple Java method, and I think it's familiar to all of us. And what it does is that I just have a method A that makes two calls, one to method B and one to C. And I will combine these results and return it to the caller. So what you have is this very easy flow inside your code, that while A is running, you have first method B, then C, and then you will create a result inside the whole lifetime of method A. So what I want to show you with this picture on the right is that inside of the lifetime of method A, three things happen. You run method B, C, and then you will get a result. And the great thing about this code is that it has a very clear structure. And this clear structure also helps you when something awful happens, like for example, an exception. So now in this example, method B throws an exception. So when I'm inside method A and B throws an exception, I know I don't have to continue forward. Because method B threw an exception, I can just rethrow it to the caller, and they will handle this exception for me. But the great thing is that I'm not going to try and run method C. I'm not going to try and create a result, because I can't, because method B threw an exception. And of course, the same thing happens for method C. If method C throws an exception, I know I don't have to go and try and create a result because I can't. So the great thing about the structure is that its flow is very easy to follow. But then we get the same example, but now I added some threads. So it's the same example. I have my method A. I do a call to method B. It will find some result using a thread, and so will method C. It will find a result using some kind of threads, and then I will try and create a result using the foo.get and foo.bar. So again, I have my lifetime of method A on the right, but now B and C run in parallel. They run at the same time. They can have different lifetimes, but when they are both done, I know I can create a result. So when foo.get returns and bar.get returns, I can create a result for the caller method. And inside this return statement, I created this implicit relationship between those two method calls, and also between those threads, because both threads need to succeed in order for me to create a result that I want. So if, for example, method B throws an exception, I still have method C running, but because of this implicit relationship, I need B to also finish successfully, or else I can't create the result. So in this example, if method B throws an exception, I have a thread loose inside my system, the threads that run inside method C, that I will somehow have to stop myself, because the application doesn't do it for me. And of course, the same thing happens if method C throws an exception, but it's a little bit worse now, because now I have to run method B first. It will take some time to run. Then I will also at the same time execute method C, but it may throw an exception immediately or somewhere in the future. But I don't know right away, because I first have to wait for method B to finish inside my return statement at the foo.get. I have to wait for method B to finish. And then after waiting a X amount of time, maybe even minutes, I find out that method C has thrown an exception and I can't create a result. So now I've wasted time and resources waiting on method B to finish, while I could have known that I can't create a result because method C threw an exception. So this implicit relationship, it shows that I really need both of these methods to finish successfully. And then, of course, it can be even worse, and that is that the parent thread fails. And at that time, I have two threads loose inside my system that I will also have to cancel myself, which isn't really nice. And that's where structured concurrency comes in. So let me show you how that works. So here I have a main method, but I want you to focus on what's happening inside this try and resource statement. So in the top of this try statement, I create my structured task scope. And a structured task scope is the way it is implemented in Java. The structured concurrency is implemented in Java. And with Java 21, we get two policies, the shutdown on success and the shutdown on failure. And these policies state when my scope, my structured task scope, has to shut down. So with this structured task scope, I want to make my relationship between my virtual threads really explicit. And one way of doing that is by using the shutdown on success policy. And this policy states that I want to shut down my virtual threads when one has finished. So I'm only interested in the first virtual thread to finish. And the other ones can be cancelled, or I can ignore their results. Well, and to create a structured task scope, you can just create the constructor of the shutdown on success policy inside the try with resource statement. And then you create a scope object that you can use to fork new virtual threads. So here in this example, I create 2 new virtual threads using the scope.fork method. And the first virtual thread will return result 1, and the second will return result 2. So these virtual threads, after being forked, will start running. And I want to wait for the first one to finish. And to do that, I'm going to call the join. And calling the join on the scope object will block the parent thread. And it will block until the shutdown on success policy is fulfilled. So one of these 2 threads has finished first. And after this join, I know that one of my threads has finished, hopefully successfully, and then I can get a result. And because I don't care which one of those threads finished first, I'm only interested in the first one, in the first result, I can just call the result method on the scope object, because the scope knows which one of my threads finished first. So when I run this example, it will probably print result 1. So as you can see, the first virtual thread finished first. And either this virtual thread either succeeded but was too late, so its result was ignored. But if it was still running, it would just be cancelled. So with the structured task scope, I can make the relationship between those virtual threads really explicit, which makes canceling one of the other a lot easier. And it really shows the intent that I have with those virtual threads. So as I said, you get 2 shutdown policies, the shutdown on success, and the other one is the shutdown on failure. And the shutdown on failure states that either all my virtual threads finish successfully, or if one fails, I want all of them to be cancelled. So again, I create a new shutdown policy or a new structured task scope inside the try with resource statement. But now I want to have my to get a reference that I can use to fetch the results later on. So again, I create 2 new virtual threads using the scope.fork method. And they will return a subtask. And a subtask is used later to fetch the results, because now the scope doesn't hold all the results that I want, but I have to go to each of those instances. And to make this example a bit more interesting, I'm not only going to join, but I'm also going to set a deadline. You can set a deadline using the join until method on the join. And what this does is that in this case, I give my virtual threads 10 seconds to run. If they don't succeed in 10 seconds, I'm going to cancel them myself. So they have 10 seconds to finish, or else they will be cancelled. So again, I will just block here for 10 seconds. And to know if all my threads finished successfully, I'm going to call the throw a failed method. And the throw a failed method will rethrow the exception that happens inside the virtual thread, if one did happen. And then I will just rethrow it, so I know that something went wrong. So by doing the join, I know that my virtual threads will be done after this point. They either finish successfully or unsuccessfully. And after the throw a failed, I know that both my threads are done. And if I didn't rethrow a exception, I know that they finished successfully, which is really great, because then after calling those two methods, I know that the result is there and there is no exception hiding or anything. And I can just immediately use a get method to fetch the results that I want, which is really great. Looking at the time, I do have time for the fourth demo. So by default, you get two shutdown policies, but sometimes you need your own one because they don't fulfill the needs of your business use case. So what I'm going to show you is how to create your own structured task scope. And this structured task scope is going to look for a product that is worth less than 100. And if it finds one, then it goes to shut down all the other virtual threads that are still searching for a product that is worth less than 100. So I created a product and that just has a price. I created 3 methods for my virtual threads to use. One is going to fetch a product of 50, one 300, and one is going to return a product of 200. So my virtual threads are going to run these 3 methods, and I'm only going to be interested in the one that's less than 100. And what I want to show you is that you can create your own structured task scope that shuts down when you want it to shut down. So here I have my criteria scope. And to create your own structured task scope, you only have to extend from it. So in this case, I extend the structured task scope, and it's going to return a type of product. So here I have the criteria scope. I have a little variable that I can use to store the product in temporarily. But the most important thing is this handle on complete method. Every virtual thread is going to call this handle on complete method. And when it finishes, either successfully or unsuccessfully. So inside this handle on complete, I am going to shut down my criteria scope if I did find a product worth less than 100. And I can shut down by calling the shutdown method. So inside this handle on complete, I first check if my virtual thread finished successfully, because I can't get a result from a virtual thread that had an exception. So if it did succeed, it means that it does have a product that I can use. And then using the subtask, I can get the product, and I can then use the price method to get the price of the product. So then I can check if it's worth less than 100. And when it's worth less than 100, I'm going to store it temporarily, because then I found the product that I was searching for. And I can just shut down, which means that all the remaining virtual threads will be cancelled. And just a simple getter method to fetch the product later on. So now I have my criteria scope that I can use. Now let's actually use it inside our code. So here I have a simple try resource statement again. And all I have to do is call the constructor method, call the constructor to create my criteria scope. And again, using the scope, I'm going to fork 3 new virtual threads. Each one gets to find its own product, 50, 300, and 200. And then I have these 3 subtasks that I can later use to fetch, in this case, the state, because I want to show you what the status of these virtual threads. So again, I have to call the join for the parent thread to block. And then I'm going to print out what the state is going to be and the product that was found. So when I run this example, it's going to take some time to build. But as you can see, And this is the output. You can see that 2 virtual threads finished successfully, and 1 was unavailable, which means that it either didn't finish in time, or it wasn't even started yet, or it didn't even run. So as you can see, both of these virtual threads finished successfully. The product that was found was worth 50, which is less than 100. But what this shows is that even when we found a product, so a virtual thread finished successfully, we didn't shut down the structured task scope, but we did when we found a product of 50. So what it shows is that you can really easily have your own policy inside a structured task scope. So you can decide when a virtual structured task scope has to shut down. So the pitfall really is not using it, because it makes managing the lifetime of your threads really easy. You can even nest those criteria scopes or the structured task scopes inside one of another. And so you can have these nested scopes, which is really nice, and it just makes managing those lifetimes of threads really easy. And of course, it makes the relationship between those virtual threads really explicit, which helps the person who is going to read your code next. So I talked a lot about virtual threads and structured concurrency, but all you're going to need to know to start using it in 6 days are these 2 methods. You're going to call the start virtual thread method and the new executor service. This is all you're going to need to start using virtual threads. And that marks the end of my, slides. So thank you for listening. Then I think it's time for the questions.
David, hello again. Thanks for the talk and enlighten us on this not so easy topic, I would say. And also happy to see some demos, some live coding. Always very helpful to understand.
Glad you liked it.
Yeah. And yeah, since we have some minutes left and got some questions, I would say, let's jump right into them. Maybe starting with you also a bit about you yourself and your personal developer journey. Would you mind telling us a bit about how you became interested in tech at first and how it went on from there?
How it started? It may sound a little bit cheesy, but I was playing this online game, and I was really interested in how could I ever work at this company that makes this online game. It was using the Java applets, so something to run in the browser. And I went to the site and it says, we are looking for Java developers. And I was like, what's this Java? What is this thing? So I just started going on from there, just creating hello worlds. And the company went bankrupt, I think, but I did learn Java, and it's been a great journey ever since. Did my bachelor's eventually with it, and then just started working. So yeah.
All right. Yeah. Thank you, David. And yeah, let's move on to some of the more technical questions, I would say. The first one. Is Project Reactor and Spring Webflogs usage to be replaced by virtual threads usage?
Well, if I remember correctly, there is this merge request already for Spring that enables the support for these virtual threads. So I do hope it's going to replace it, because virtual threads just make it a bit easier, and you can just use the way of programming that you are already familiar with. You don't have to start rewriting your methods or anything. So I think it makes it a lot easier. So I think you want to replace it yourself.
All right, thanks for that. Next question. During incident scenarios, is there a way to switch automatically to virtual threads if blocking operations become more common?
during incident scenarios. I think you have to start building that yourself, but well, I would say just try it out, see what a performance impact these virtual threads have, but there is no automatically switching between one of them.
All right. Thanks for this answer as well. Next question from the audience. Just want to confirm, does the structured task scope method use virtual threads or platform threads?
They use virtual threads by default.
By default, okay. Thanks for that. Next one. How complex can you make the structured task scope policies? Is it just success and failure, or can you specify conditions?
Ooh, that's a very good question. I never tried it myself, but I can imagine that you can fetch the exception that happened or something more, something like it. But yeah, never tried it before. But on the, well, I think you can just make it as complex as you want, but would have to try it out.
All right. Thanks for that. Next question. Can you decide to skip reactive programming in favor of relying on virtual threads in some situations?
I think you can, because with the blocking, it happens not on the thread itself. So I hope myself that it will replace the reactive programming style. So if you are not using it already, I really encourage you to give it a try and see how your application behaves.
Right, yeah, learning by doing, always good. And yeah, we go on to the next question. Are there any disadvantages to using thread local in virtual threads?
The old thread locals, I don't think they really, yes, because if I remember correctly, those thread locals will be copied to each of those virtual threads. But there is this new improvement of this new iteration of these thread locals. Those are inside. They live inside a scope. These I don't really remember the name, but there is this new Java enhancement proposal that's also going to preview in Java 21 that you can use with the it's like the thread local variant for virtual threads. So,
okay.
Yeah.
Thanks for clarifying that as well. Next question. When migrating an existing Java application to use virtual threads, what are some common pitfalls that developers should be aware of?
Well, I think those are the same as that I showed during the slides, that you don't want to use a kind of pool. Don't expect your your application to be faster by just switching. And the other ones are, of course, the blocking methods that are, some of them are not always supported by the virtual thread. So, well, those are some of the pitfalls.
Okay. Thanks for that also, David. And the next question. Since we talked a lot about version 21 of Java, maybe a more general question and a bit more personal to you. What feature of version 21 are you most hyped about?
And that's an easy one, of course, the virtual threads.
But okay, let's say the second most.
Oh, that's also an easy one. It's the structured concurrency part, but I'm also what is it? The whole this whole more data-oriented approach that they also incorporate with Java 21. It exists out of multiple proposals, but like the record deconstruction part and everything. So that's also one of the very nice features of Java 21.
On which version are you right now yourself?
The early access build of Java 21.
Okay. I see. All right. Again, a question about version 21. What feature do you still miss in the upcoming version 21?
all
can
those
think
features
of
are still in preview.
Yep.
Yeah, I can't wait for them to be out of preview. And
All right. And yeah, we have one more question. Are there any compatibility concerns or issues that developers should be aware of when migrating to Java 21 and adopting virtual threads?
not that I can think of. It's almost like a drop-in replacement. It's always good to just check the performance before and after, but it should be a drop-in replacement.
All right. Thanks for this as well. David, you wrote in your bio that you are also writing blogs. Maybe you can give us some insights on what is your focus on these blogs and where we can find them.
Well, you can find them at davidflemings.com, first name, last name. And my focus is mostly on, well, testing using Mockito and, of course, virtual threads and structured concurrency and all the things you can do with it.
All right. Thanks also for this. And David, I would say thanks so much for the talk and also for the Q&A afterwards. I think you enlightened us a lot more on some of the upcoming features of version 21 and hopefully see you on another live day.
Well, thank you for having me and have a great day at Java.
Yeah.
Thanks.
Thanks, David. Right. And before we go on to the next speaker of the day, we take a short 5-minute break. Hello again. Hopefully you all had time to grab a coffee and take a few deep breaths. And now we continue with the Java Developer Day and the next speaker. She is software engineer and consultant at NetLight. She has also experience as Scrum Master, project manager, business analyst, and requirements manager. And she loves to find achievable and elegant solutions to complex problems. Welcome, Iris.
Hi,
Hi, Iris. Wonderful to have you.
happy to be here.
Thanks for joining. So, Iris, before we start with your talk, would you mind giving us some insight in what we are going to learn from you today?
Yeah, sure, of course. So I have to say, I feel a little bit like an intruder since I'm coming here to a Java Developer Day and I'm going to talk about Kotlin. So it's not going to be focused on Java, but I kind of want to spread the word and awareness that Kotlin is actually a fantastic alternative and how you can get started with this journey yourself.
So hopefully nothing too controversial with the Java community. But I think me and the audience, we are very much looking forward to your talk, Iris. And I would say without further ado, the stage is all yours.
Thank you. All right. So hi, everyone, and welcome to my session, Why Kotlin is the better Java and how you can start using it. As Benny already said, my name is Iris. I'm a software engineer, and I work as tech consultant for NetLight in Zurich, Switzerland. So the blessing and curse as a consultant is that I get to work with different tech stacks. Sometimes I just have to use whatever my client wants me to use, but sometimes I can influence this a bit. And if I do have some influence, I definitely try to push a client a bit closer to Kotlin and maybe a bit further away from Java. So what will we do in this session? First of all, I want to share my enthusiasm for Kotlin with you. I want to start with some high-level comparison of Kotlin and Java. What do they have in common? What is different? And then we will dive into some examples with some live coding to actually see how does it feel to work with Kotlin. And at the very end, we will see how can you get started with your own Kotlin journey. So this is like a metric I often like to look at. Here you can see, based on the data from last year, the programming languages most used by developers. So we can see about a third of developers say they know Java. But for Kotlin, that number is below 10%. And my goal here today, and well, maybe also a bit more in general, is to increase the number of software engineers that know Kotlin, that like Kotlin, that use Kotlin, and are part of the Kotlin community. Personally, Java was my first language. So I still think it's a good language and it is used in so many different areas. But personally, I switched to Kotlin for about a 3-year project. And ever since, I don't really want to go back. So I feel like it's definitely a step worth taking. So let's look at Java and Kotlin. I mean, what do they have in common? Both are high-level, cross-platform, general-purpose programming languages. And Java is basically, it got big on the idea of portability, like this principle, write once, run anywhere. Because Java code is compiled to Java bytecode that can run on a JVM. It has been designed with a C, C++ style syntax in mind and supports object-oriented programming. Kotlin, on the other hand, is very consciously designed to be a better language than Java, but it's still interoperable with Java code. It supports object-oriented and as well functional programming. One more thing that I find very remarkable, Kotlin has been developed by JetBrains, the people behind IntelliJ. So the tooling is always fantastic because it basically comes from the same source. So you get a lot of cool stuff there. Looking at the time, I wrote here that Java was initially released in 1996 and Kotlin in 2016. So that is a 20-year gap we have in here. I always struggle to imagine what does that mean exactly? So let's try to put this into context. In 1996, well, Bill Clinton was president of the United States. Independence Day has been the highest grossing movie of the year. And what you can see in the middle is a Tamagotchi. I mean, I grew up having those, so I'm not sure about you, but as you can see, they don't look so new and fancy anymore. Let's compare this to 2016. Now we have Finding Dory, like a spin-off of the Finding Nemo movie, as highest grossing movie of the year. Barack Obama as president. And I'm not sure if you remember like the picture I have like for a game here, but 2016 was the year where everyone was like running around with their phone outside for Pokemon Go. That was the year this was released. And whenever I look at this slide, I feel like it puts time and those 20-year difference a bit more into perspective. And yeah, we can just see that Kotlin is definitely a lot newer than Java and didn't have to make some of the mistakes that Java did. All right, what does Kotlin have that Java does not? And here I have really just listed some of my personal favorites, but the list could go on and on. We will dive into some of them in more detail later on. So Kotlin has very famously null safety. We will also look at this in a moment. I very much like the extension functions from Kotlin. String templates are like a small nifty feature, that I just enjoy a lot. Data classes make your code like smaller. You don't have to write quite as much boilerplate. You can have like primary constructors. And what I think is also very important is the like excellent support for like functional programming in Kotlin. Range expressions I won't go into, but if you're like dealing with a lot of loops, this might be something that might be interesting for you. And I very much prefer how Kotlin handles generics compared to Java. All right, when we think about Java, I think one thing that jumps into mind immediately is the very famous null pointer exception. It has also been called Java's billion-dollar mistake. That is, I think, one of the issues that every single Java developer is very like familiar with, is this beautiful null pointer exception. I mean, we can look at how many results I found on Stack Overflow just for like null pointer exceptions. So yeah, it's fun. I assume you all know that one. In Kotlin, we don't have this anymore. We have null safety. So each variable we have is basically defined as nullable or not nullable. And that means then also we have to treat this variable according to this. And we will at runtime not have null pointer exceptions. So here we have like this example where we create a person that might be null. And when we then try to access something like some parameter, some variable of this person with like this operator, we can check to make sure the call is null safe. We can even like define some fallback values with the Elvis operator here. And I really like the name Elvis operator, and I'm not sure if you immediately understand why, but if you like tilt your head to the side a little, it kind of looks like the famous king of rock and roll. So that is actually why it's called the Elvis operator. All right, but looking at slides is always a bit boring. So this is the time when we dive into our first code example. Let me switch to IntelliJ. So I have prepared some examples here. As we can see here, I have like a nullable string, as can be seen with this question mark, and a not nullable string. And now let's see what happens if we assign some null and not null values to this. So first we take the nullable string and we assign it null, all perfectly fine. If we assign it whatever not nullable, not null value, also perfectly fine. Now let's try the exact same thing with our non-nullable string. And here we can see immediately the compiler complains because we know that this string cannot be null, so we cannot actually assign it null. So this gives me a compile time error, now also visible directly in the IDE. If I, on the other hand, would assign any text, that is totally fine. But we don't want any non-compiling code, so I remove this again. And now let's see what happens if we like try to access the strings. Let's just simply print them. We start again with like the nullable string. I like check for its length. And now that is actually totally fine because the last thing we do here is we assign a null value. If I switch this around, we can see here, okay, this call is not safe. Here. So I have to make like a null safe call out of this. Now it's always hard to like talk and type at the same time, so I bear with me here. All right, and if we do this for our non-nullable string, none of this happens because we know it is always has a value. So we can just directly like access this length property, and we know we will never have any issue with like null pointer exception or anything like this here. Okay, so after this short demo, let's get back to our slides. The next example I want to look at with you are data classes. In Java, I have here an example of just a very simple pocho with like 2 attributes. You can see here a name and an address. But if I like write all the getters and setters and toString and equal and so on methods, it results in 50 lines of code for like content-wise 2 lines. And that is something, well, that I think is not so great because boilerplates makes the code hard to read. It's just a lot of code to maintain. And what does Kotlin have? So Kotlin has like this cute little keyword data. So we can just define a class as a data class, and it knows immediately that like the variables we have in here. It will create getter functions. It will create setter functions if it's a mutable variable. It will create like hash code and equals and toString methods, some other methods as well that I actually won't go into detail. But the code is still very small and very readable. And that is something that we will come back to like over the course of like this presentation. Kotlin code is shorter and more readable in general than the typical Java code. Small disclaimer here. Since I like first looked into this feature, Java has also like changed a bit. So in release or in Java 14 and now stable since Java 16, Java has the concept of records, which provides a very similar functionality, but actually only for immutable classes. Kotlin data classes also work perfectly fine for mutable classes. And at this point, it's time for our next demo. All right, let's go over here. I have to check what I wanted to do here exactly. All right, so we actually want to create a data class. Let's head to our main area. To here in this package, we create a course class. I can even, I didn't realize this before. I can even select that I want it to be a data class. So I already have like the data keyword in here. Let me check back. What did we want to do? We want this to have a title, credits, and if it's graded or not. So here we kind of like in a university or school kind of example So now I forgot again. What did I want to do? A title. So we have a title. We want credits. Let's just say that's int. And we wanted to say, I think if it's graded this course. So let's add a Boolean in here. And maybe we say that typically courses are graded, so we can enter a default parameter in here. And let's say the typical course has 6 credits. All right. And that is actually all we need for this. And now, yes, we've done this. We can create some courses. I find this immediately with code completion. And let's say we create a math course. And what I can also see here, if we say like math is like a course that has like 6 credits and is graded, I don't even need to provide these values. I can just use the default values. And let's now maybe see if we want to say this math course, we want to change the credits. Let's see if we can do this. Maybe it should get more credits, but here we can see no, we can't do this because when we look at our data class, credits is not mutable. I can change this to a mutable variable. And immediately here we can see now we can change the credit. So without having to now write a setter method or anything, the compiler immediately knows if this is a mutable variable, we have basically a setter in the background that I can use. And if it's a non-mutable value, then I can't change it. And I get immediately like this feedback from the compiler in the IDE and don't have to do anything more about this. Let's maybe take another example. Maybe we have some communication cards. And here I can say, maybe this one is not graded for whatever reason. Maybe it has some different ways of being assessed. And then I can just provide this information here without having to like change anything about the credits. Let me check. Have we done everything we wanted to do? Yes, we did. That looks good. Then I head back to the slides. All right. Now we come to, I think, one of my favorite Kotlin functions or Kotlin features. It's extension functions. So Kotlin natively provides the ability to extend classes. So that is very, very valuable. For example, if you're working with some third-party library that you don't have access to the code, you can't change the actual code, but you're missing some really important features, some really important function. And what do you typically do in Java? In Java, you would probably write some kind of util class, but I cannot tell you how often I have either written a util class and then later realized it already exists, or tried to find a util class just to figure out it probably doesn't exist yet, and I probably have to write it. And the really cool thing about extension functions is they behave like regular functions. So you can find them with code completion and everything. You can actually, find the function as if it were a real one. And this, of course, because it's so cool, we also look at a demo. Let's head to the extension function demo. Here we're still kind of in our university setting. I have already created a student class. We can have a quick look. That is like a very simple class, data class with the name, birth date, some grades. And here we have like an average grade that is already calculated out of all the grades we have here. Back to our examples. And now we say, okay, we want to have a method to check if the student is passing all courses. But our student class doesn't have this information, doesn't have a method that does this. So what we want to do is we write an extension function for the student class. Let's see. And what do we want? It should, oh, I'm missing my keywords function. What we want is we want to get a Boolean back. And what I define here is kind of the class I'm extending. And here's like the name of the function that I'm now extending this class with. And inside this extension function, I can access the public methods or public elements of the student. So we have here defined passing means we need a grade of at least 60. I think we have defined grades are a number between 0 and 100. And in the school system that probably doesn't exist, that I just made up, we need a grade of at least 60 to pass. So what we can do is we just check our grades and make sure all of them are larger than 60. And we can use this now. I can now here. And here you can see like with code completion, this is like actually a method that is visible here. So when I'm like working with this object and try to figure out, oh, do we have a method for this? I don't have to go searching for util classes. I just check what methods do I have available and I can find it. What we can see here, because one of the topics with extension functions is, does it not like get very cluttered when you have like, I don't know, a lot of extension functions? You can limit the scope of extension functions. So what we have here is I just created this as a private extension function, which means that only like within this scope, I can actually access this. So this, if I go to some other class, I would not have access to this function. But it could also be done as a global public extension function, and then it's visible everywhere. But for now, because we only need it in this test, let's leave it like this. Okay. I hope that made sense. And then we move on to a next rather small example, string templates I mentioned before. In Java, like when we deal with string concatenation, it is a bit awkward. We can either do like concatenation with the plus operator, which just, yeah, this is the first example. It gets kind of a bit hard to read. The string builder is actually intended to like do concatenation like this, but I just find it very, very verbose. String format is a very cool option, very cool option because you can put in some formatting as well. But what I really do not like about it is that it separates the place where like a variable goes from the actual variable. So you have to like figure out, do I really have all of them? Do I have them in the right order? And mistakes just happen very easily because they're not so simple to spot. What does Kotlin have? Kotlin has, well, as I mentioned, string templates, and variables can just be directly added into the string. And as here again, I have a little disclaimer. This is actually something that with Java 21, which now in September reaches general availability, will also provide, because apparently they also realized this is a really cool feature. It's very small, but I find it very handy when working with it. So at this point, question is demo time. Actually, no. I do not have a separate demo for this because it's really just such a small little thing, but I will sneak a little example into the next demo. So stay tuned for that. So the next topic I want to look at are smart casts. With Kotlin, the compiler tracks when we do a check that like our object we're looking at is of a specific type. And then afterwards, we do not need a cast anymore. And again, a topic I mentioned earlier, it just makes the code shorter. It makes it easier to read. It avoids boilerplate, which I think is very nice. But here now, as promised before, we will do another little demo, and I will sneak in a little string template demo as well. All right, let's go to the smart cast demo. I also here have like already prepared something. We have here a method print value that accepts a parameter of any. Any is just like every object is part of any in Kotlin. And I can see up here, I'm now calling this with like objects from 2 different classes. So here I put in a string. And here I created one of the like our student class that we had before. And now our job is to complete this class here. So first thing, we want to check if x is a string. Now I can immediately, also now directly again with code completion, I immediately see like all the options of like when x is a string, because this code will only be executed if we pass this statement here. So I can print the length here. And on the other hand, if we do a check if x is a student, here again, I can see like immediately the code completion options for our student. And I said I want to like throw in a tiny bit of an example of string templates. So let's do this. Maybe we throw in the name, next name of the student, or on, and let's use the birthday. And great. And let's also print the grades. Speaking and typing, really not easy. Great. And to see how this actually looks, let us quickly run this test, because before we just wanted to see that like we don't have any compiler errors, but let's maybe here in this case take the time, because instantiating the test sometimes takes a bit long in the beginning. All right, here we can see this is our string length. So yes, test has a length of 4. This is the value we see here. And here we can see a nice little text from our student. And we didn't have to do any casting whatsoever after we already check that our object is of the type that we want it to be. And this kind of, to come back to this topic, I think I've mentioned this a few times. I think in quite a few of the examples we've seen now, the code we're writing in Kotlin is just often a lot shorter than what we used to write in Java. So it's less code to write, which also means it's less code to read. And I think there are some statistics about like how much time as a developer you actually spend writing code versus reading code. And we just read so much more code than we ever write. So I think readability is actually a very, very important argument. Also, what I've mentioned before, we like didn't look at an example now, is like functional programming. Together with the extension functions, you can like actually combine them into very nice and easy readable like code parts that yeah, it's just fun to write, fun to read. At this point, after like now about half an hour of talking about all the cool things that Kotlin has, you might start asking yourselves, am I being unfair to Java? I mean, of course, I don't think so. But also, as mentioned before, I'm not here to start a war. So first time when I talked to my mentor about like this talk of like, yeah, why Kotlin is the better Java, she was like, are you serious? Like you can't do that. But I think it is important to look at, well, better tools we have available today. And just because a tool is good does not mean there is not a better tool. So maybe let's look at what does Java have that Kotlin does not. Spoiler, I don't think it's going to look very nice for Java. So what does Java have? Java has checked exceptions, which Kotlin does not. I know some people like checked exceptions, but I think in recent years, the trend has definitely gone moved away from checked exceptions to unchecked exceptions. Because again, kind of like just more code, boilerplate, it kind of litters this like throws exceptions in the method signature, which is not necessary for unchecked exceptions. One more thing that Kotlin does not have, which Java has, is like primitive types. But I think everyone that has worked with Java knows that like primitive types also come with their own problems, like of the whole unboxing and boxing, auto unboxing features. And Kotlin basically gets rid of that by just not having primitives. I just mentioned this very, very briefly in the beginning. I have to admit, in Java, I always struggled a tiny bit with like the wildcard types. I find how generics and like wildcards, everything is done in Kotlin much more intuitive. So yeah, I don't miss those when I'm writing Kotlin. But are there still reasons to use Java instead of Kotlin? And this really depends kind of on you and your team. And of course, you can just say, yeah, but we know Java and we just want to stick with Java. Sure, you can. But I think it might be nice to get used to a newer and cooler tool. And I promise you, it's worth it. And one argument, it's a bit of a silly one. If you have a boss or a company that counts your committed lines of code and I don't know, your bonus or your promotion or anything like that depends on this number, maybe you want to like stick to Java instead of Kotlin. But I really hope that this is just a myth, that this actually doesn't happen anywhere. But yeah, as I said before, Kotlin just results in less code. So there will be fewer lines committed for the same content at least. There is this very famous quote that there are only like two kinds of programming languages. The ones people complain about and the ones nobody uses. And as we've seen in the beginning, Java is obviously quite widely used, while Kotlin is not quite yet that far. But when we look at this quote, I think we should also keep in mind that this is a quote from the inventor of C++, a language that is definitely both widely used, but also widely complained about. I kind of hope by now you're wondering, all right, this sounds cool. I want to do this. How do I start using Kotlin? And this is what we get to now. The first thing I want to point out is that switching from Java to Kotlin is fairly easy. And Java is designed to be interoperable with Java. So you can call Java from Kotlin code, you can call Kotlin code from Java, and like in whichever direction you want. There are a few considerations. Like the getter-setter methods from Java, they basically get represented as properties in Kotlin. And some types have to be mapped between Java and Kotlin. For example, I mentioned the primitives that do not exist in Kotlin, so there has to like be some mapping happening. And there are also some limitations. One of the like nicest feature of Kotlin, the null safety, is fairly limited when used with Kotlin Java interoperability, because when we get any kind of variable from Java, we obviously do not know if it's nullable or not nullable, because that's just not defined in Java. So yeah, there are like some things to consider and some limitations, but interoperability actually works fairly well. And last time I talked about this topic, I got quite a lot of questions around this. So I thought, well, let's just throw in a small demo and maybe that clears already a few things up. So let's head to what is our last demo today. Here we have like a small interoperability demo test case. What I already have somewhere up here. This is like the person class that I used a little earlier in the example for the data classes. Now here we have the plain old Java version of it. And here, as we can see, let me head back to this one. We are here in a Kotlin test case. And what I now can do, I can just simply create a new person. And we need a name. Maybe that's Anna, and maybe, I don't know, I'm always bad at remembering my examples, so I cheat. I actually chose Michael, who lives in maybe Zurich. And what we can also like see now, name, oops, I should actually assign this to a name here. I can now access the name, and because, let's have a look, name has a setter, so I should be able to change this. Let's assume, I don't know, Michael got married and now it's called Michael Allen. And I can now access this Java setter like a Kotlin property. And at the same time, if we take this away, if this setter doesn't exist anymore, let's head back to our test case. I now get a compiler error because now it's a non-mutable value, so I can't change it. But we do want to change it, so let me reverse this. All right, let me check. We created a person and we changed our name. This is what we did. And now let's have a look at the not so nice part. If we set, let's say, the address to null, and now I want to print like the length just to make sure we have to like access the address. As you can see, I get like no issues from the compiler. The IDE is like perfectly happy with this. But if we run this, this should now lead to an exception. Exactly. So here we actually do get our famous null pointer exception also in Kotlin due to the like Java Kotlin interoperability features we're using here. So yeah, this is not, you don't get like everything if you like mix Java and Kotlin heavily, but I think you still get quite a lot of cool features. So with this, I head back to the slides. And let's look at what can you do if you want to learn Kotlin. My kind of favorite suggestion is there are the Kotlin cones. It's a series of like exercises that just helps to get used to the Kotlin syntax. It is like aimed at Java developers. I think you don't even really need to know Java to enjoy them, just like kind of any kind of programming language. And this is also how I started. It's a good introduction with like small time investments, you can actually like, yeah, just get the hang of it a bit and figure out, hey, how do I do this? How does it feel? And it's fun to do. There are some like very nice books on Kotlin. Atomic Kotlin is highly recommended for like both new and experienced programmers. Myself, I read Kotlin in action. I very much enjoyed it. It gave me a more like a deeper understanding of the language, like, and it starts from like very basic syntax to more advanced topics, including like higher order functions, where you like treat functions as like first order citizen, and also like DSL construction. So it goes really quite in depth. But I think we all know you don't really learn programming by reading a book. So at some point, you just have to start building. Myself, I have mostly used Kotlin for backend applications, where it's actually not so widely used at the moment, but it works very, very nice. You can also combine it with some frameworks you probably already know. Of course, Android apps are a very good opportunity to use Kotlin, since it's the like official preferred language since 4 years now, 2019. And Kotlin also supports like multi-platform or cross-platform compilation, which is something I personally don't have experience with, but is something you can also do with Kotlin as a language. All right, I think it kind of slowly gets time to wrap this up. So let's do a bit of a summary. First of all, yeah, why use Kotlin? Well, Kotlin is designed to be a better language than Java, and it has just a lot of nice features that Java does not. You can say goodbye to null pointer exception. Point number 2. Point number 3, it has a lot of like useful language features. Personal favorite, extension functions, and like many of the others we saw today, and many more that I just did not have the time to cover in this presentation. Kotlin is easy to write. It's easy to read. It results in shorter code. It has less boilerplate, so it's a fun language to work with as a developer. And maybe the best part, it is easy to switch to from Java. It is from, if you're used to Java, you will not have a lot of trouble getting used to Kotlin, and for both like new and existing projects. So at this point, it's kind of up to you. Like, which path do you choose? What do you prefer? And what, do you feel most at home with? With this, that's kind of like all from my side. You can find me on this platform. So also after today, if you still have some questions about anything, just shoot me a message, let me know. And all the examples we looked at today, you can also find them on my GitHub. So thank you very much.
Iris, hello again, and thank you for this talk. I think it fitted pretty well into our Java Developer Day as just as an alternative to the others. And people were very engaged, and they gave us lots of questions. So
I love it.
If you're ready for it, I would say without further ado, we would just start with the first one.
Sounds good.
Which would be, are there any situations or use cases where Java might still be preferred over Kotlin? Or is Kotlin generally the better choice in most scenarios?
I mean, I think you can imagine my answer to this, but I think my opinion definitely is I would generally prefer Kotlin. I think kind of the main reason not to switch to Kotlin is if you really have a team that is very much against the switch. Typically, I've made the experience that most developers enjoy learning a new and cool tool like Kotlin, but if you really have strong resistance against it, I think is the main reason to stick to Java. But like really more from a let's say organizational point of view, and I don't see drawbacks from a technical point of view.
Okay, so you just need very good persuasion skills to also make your team use Kotlin, and then you're good to go.
Thanks.
Perfect. And we go on to the next question. Does Kotlin have support for any effect system similar to Cat's effect in Scala?
I have to pass on that one. I don't know Cat's effect, or I've never written Scala, so have to pass.
All right, totally no problem at all. Then we just move on to the next question. How easy is it to migrate existing Spring Boot projects to Kotlin, and what are the best practices?
I have actually never migrated a project, but kind of the general approach recommended is that you don't like migrate maybe everything in the beginning, but you can really just like leave your application as it is, and you can start writing new code in Kotlin. So like you have a phase where you kind of like have parts Java, parts Kotlin, and then you can probably migrate like step by step. One thing, one feature that is very cool is you can, if you copy Java code into a Kotlin file, IntelliJ will transform it into Kotlin code, or you can choose to transform it into Kotlin code. It's not always the nicest code immediately, because you do need a tiny bit of a shift in thinking, in how you approach things. But that is kind of like I think, good way to get started.
Mm-hmm.
And Spring Boot, like Spring in general, is also supported in Kotlin, so you can basically stick to the same framework.
All right. Thank you, Iris, for this answer as well. And let's go on to the next question. Do you think that using Lombok or many other mini projects after knowing Kotlin is a dumb decision?
I don't think so. I have also used, for example, Lombok in some Java projects, and it gives you some of the features that I've now mentioned I really like about Kotlin. For example, like Lombok is also very good to help you get rid of like the boilerplate of getters and setters, to deal with like the checked exceptions with, I think, sneaky throw or something. Is it in Lombok, to make sure you don't like clutter your method signature? I think it's a bit of a crutch for Java. Like it would be better to switch to Kotlin, but from like the direction, I think it's actually a good direction and helps you think. I mean, it is the realization and admission that there are like some things in Java that we want to change, but we kind of like put a band-aid on Java instead of trying to use a language like Kotlin.
But thank you for clarifying that as well, Iris. And we go on to the next question. I work in Scala, and I see all these features of Kotlin exist in Scala too. What is your opinion on Scala versus Kotlin?
As mentioned before, I have not written Scala, but to be honest, I have heard this question before. So maybe this is the time for me to see, to actually take a closer look at Scala and figure out what is the hype over there. Because I've talked to quite a few happy Scala developers. I can't recall, also like not in teams I've distantly worked with, seeing like bigger Scala projects like in a production case. But on the other hand, I have seen this in Kotlin, but that is just like my personal view. But I think I need to take a closer look at Scala. Thank you for pushing me a bit more in that direction.
Yeah, and maybe just dive in it, and on the next live day, your topic will be why Kotlin is better than Scala.
Maybe, or why Scala is better than Kotlin. Who knows? But
Who knows?
Exactly. Jury's still out.
All right, thanks for this as well. And let's go on to the next question. How do you address concerns from developers or teams who may be resistant to change and hesitant to adopt Kotlin?
Mm-hmm. This kind of goes back to like the very first question we had, right? Yes. I think it's very important to address those concerns. And there are, from my point of view, kind of two aspects. One is like the long-term aspect, where I strongly believe that Kotlin is a good choice. And I also strongly believe that developers switching to Kotlin will also come to this conclusion, moving from Kotlin, from Java to Kotlin, because you have, as like the many like advantages I mentioned before. You have shorter code. You have through this more stable code, easier to read code, often more secure code, because it's like, for example, with the null safety, just more stable. That is kind of the long-term view. And I think when you want to convince a team or encourage a team to switch to Kotlin, you need to like look at this long-term view and align on that. So that like this is your North Star. This is what you want to achieve. On the other hand, you have the short-term view. And I have to admit, in like the first few weeks, it is a little awkward if you're just used to, writing your Java code, you switch to a new language. At first, it's like, okay, I know what I want to do, but like, how do I do this? So yes, you have to Google things, you have to discuss things. And it sometimes is awkward to, as an experienced developer, kind of like feel like a trainee again. But I think, was it Jonathan earlier this morning that mentioned like every change at the beginning is always hard, and it's kind of the same here. Yes, the beginning is a bit rocky, but I really think it's not as difficult as it could be, because you still run on the JVM. You still have like the same libraries and tools that you know. So the switch, the step is not that big. And I really encourage you just to try it out. Maybe do a small hackathon with your team where you can experience Kotlin, or just get them going and make them convince themselves, basically.
Yeah, maybe it can also be kind of refreshing to start something new at the beginning. All right, then thanks for this as well. We go on to the next question. How hard is it to migrate from Java to Kotlin? For which projects does it make sense?
I mean, I think yeah, both of those questions very much go together. Here I also have to say I never like migrated a project myself. I started like on a new projects with Kotlin, or like also personal projects that I just from the beginning started with Kotlin. For me, I think it makes sense for like projects where you know that they are expected to continue for a while, that will like require also like changes and extensions in the near future. It probably, to be perfectly honest, does not make sense to migrate a project that is really just in a maintenance mode where you don't do a lot of changes. They're probably the trade-off of like investment to switch the language doesn't pay off with like the advantages you get. So yeah, I think it's a bit of a question of what is the like the time horizon of your project, and if you expect it to like live for quite a few years still and still have like a lot of features and topics you want to do in this project, it might very well be worth the switch.
But yeah, totally makes sense, at least to me. Thanks for this as well, Iris. The next question is, maybe it's just a bit rephrasing of the other one, but I will say it nevertheless, because maybe you have something else to say about it. Was it easy to convince all your team members to use Kotlin if they were used to write Java before? Did you need management support to make the decision?
In my first Kotlin project, it was actually not me doing the convincing. That was the lead architect at the time. I think it was his choice. I actually joined after that choice was made. But for none of like us engineers, we actually were all very excited about the switch. And also during the project, when we had new joiners, all of them explicitly mentioned how easy it was to get into like not Kotlin specifically, but the code base. They very much mentioned how easy it was to like understand the code base, how easy readable the code is. And sure, maybe my team just wrote really nice code, But let's be honest, that's probably not the main reason. But the main reason was probably just Kotlin as a language. And everyone that joined the project with zero Kotlin experience before, they liked the switch. They had fun getting used to it. We had some discussions about, hey, how do you do this now? And that worked actually very well.
But yeah, happy to hear that. So it hasn't to be that hard to convince people if the product speaks for itself, that is. So then let's go on to the next question. What are the community and ecosystem support like for Kotlin, and how does it compare to Java in terms of libraries, tools, and community contributions?
That's a very good question. And kind of, as I mentioned a little bit earlier, what I very much like about the switch from Java to Kotlin, you are still basically in the same ecosystem. You can still use the same libraries because, as we've seen before, from Kotlin, you can call Java code. So even if a library you love and you're used to is only available in Java, you can still use it. Of course, there are like some tools that need to be available specifically for Kotlin. A lot of them already are available, and I think support is increasing. When it comes to the community, coming back to basically the very first slide, I think there we can still very, very much notice a difference. I mean, I'm here at the Java Developer Day talking about Kotlin, and not at, a Kotlin Developer Day. They do exist, like Kotlin conferences and meetups and stuff do exist, but they're a lot rarer, than any Java community events at the moment. I do hope that maybe changes a bit with like increasing adoption of Kotlin. But yeah, I think with the community, we still have some work to do.
Yeah, well, maybe you already made a change of mind in some of our users to give Kotlin a try, and hey, maybe there are already some more community members today.
Yeah, maybe, I don't know, next year we have like a Kotlin Developer Day from WeAreDevelopers, who knows?
A Kotlin week, maybe.
Maybe.
All right. And yeah, let's go on to the next question, Iris. Considering Java is implementing a couple Kotlin features like records and so on, do you think eventually Java will reach parity with Kotlin on features? Is this a possibility?
Mm-hmm. I think it's fantastic that Java is still a language that is evolving, that is like adding new features and very cool new features as well. But they kind of have this problem of legacy. If you want to be backwards compatible, which Java wants to be, and I think it's a good choice to be, there are just things you cannot get rid of that will result, like you can't just say, well, we throw out primitives tomorrow. Because that is a feature of the language that will always be there. And I think Java is moving in a direction where you can write nice and elegant code, but you can also write awkward and weird code. And you will never be able, in my opinion, to fully get away from this, just because of like the backwards compatibility you want to have and just the history you have. And of course, here Kotlin has like the advantage of being 20 years younger. A lot of mistakes that Java did, Kotlin never had to do because they kind of could build on the lessons already learned. And who knows, maybe 20 years later, there will be something else and we will say like, well, Kotlin made a lot of mistakes. But I think it will never be equal due to like those historic reasons.
Yeah, makes total sense. And hey, that's just how technology works. And technology needs to move with the time. So yeah. Okay, Iris, thank you so much for the talk. I think you made a really great impact and you voiced very good the Kotlin community today in the round of some Java, of the Java enthusiasts. So kudos for that, of course. And yeah, I would say until the next live day and maybe the Kotlin live day.
Sounds fantastic. Thank you for having me.
Thank you, Iris. Bye.
Bye, Bene.
Right, and before we move on to the final speaker of the day, just a 20-minute break, 20-second.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
And right back to Java and the final speaker of the day. She is tech lead at SAP Innovation, is a Microsoft MVP, co-organizes technology communities, and she published a book together with 30 other tech enthusiasts. Welcome, Camilla.
Hi.
Hi, Camilla. Thanks for joining.
Thanks.
Wonderful to have you. So, Camilla, before we start with your talk, would you mind telling us a bit about your topic and what we are going to learn from you?
Okay. And today I will talk about refactoring and where is refactoring, what moments to do a refactoring, and also the main topic of the presentation, refactoring techniques using Java examples. But if you're not a Java developer, you can also understand the refactoring techniques.
Perfect. All right, then I would say without further ado, Camilla, the stage is all yours.
Okay, thanks. And hi everyone, I'm Camila Santos, and today I will talk about refactoring techniques in Java. Introducing me, I am Camila Santos. Actually, I work as a tech lead and developer specialist in SAP Innovation. I am Microsoft MVP, co-author of 3 books, instructor of programming and content creator on YouTube and Instagram, Camila Coach, and co-organizer for some Brazilian tech communities and NODs. First, let's talk about what is refactoring and what is important to talk about refactoring, right? What is refactoring? We can define refactoring as a modification made to the internal structure of a software to make it simpler to understand and less costly to change without changing its behavior. It's most important to understand that in refactoring, we cannot add more features or add other features and modify features. We can just improve the code, but without changing the behavior of the code. And why should we refactor and what the motivations to do a refactoring in our projects? Refactoring improves software design. So refactoring improves the design patterns and design of the all code. And refactoring makes software simpler to understand. So we can understand our code more easier. And we can also understand the other code for other people. And also entry-level developers can understand the code more easier. Refactoring helps in finding bugs. So if you have a bug in production, for example, you just don't need to read a class with 2,000 lines or a method with 2,000 responsibilities. You can just search for one method with a specific responsibility, one class with a specific responsibility. And when you need to fix a bug in production more fast, it's a big point about refactoring. And also, refactoring helps us to develop faster. So don't waste much time understanding the code and reading other code. You just find more easier what you need to change and where you need to put other feature and where you need to add some tests and other things. And we have some moments to do a refactoring, right? For example, we have a preparatory refactoring. That happens when you have to deliver some feature, but the code is too bad that you can't just develop your feature. You need to change the code before you go to develop your feature. So you made a refactoring to prepare your code to develop your feature. So you need to change the responsibility of a class, structure some methods, change variable names, and after that, you can finally develop your feature. It's a preparatory refactoring. Other type of refactoring, refactor for understanding. For example, when you go to a new team, you need to understand the code and read the code to understand the business process and the validations and other things, but the code is a big mess and you don't understand nothing, you can refactor for understand. And while you're reading the code to understand the business process and the business validations, you can just make a little bit refactoring, some little refactorings to understand the business rules. For example, extracts all validations in a util class, or for example, extract a big class with many responsibilities in another class. You can make a refactoring for understanding the code without deliver a new feature or without a task specific. You just make a refactor when you want, basically. And for understand is a good way and a good moment to make the refactoring. Another moment to do a refactoring is a refactoring for garbage collector. That happens when you are reading a code or developing a new feature and you see a method, a class, or a variable that don't use it in any way of the project, but for any reason that was created and was here and no one is using. So you can remove this dirty code. Is a type of refactoring that I will present last. So you can just delete that code that you don't use it in any way of the project. So you made a garbage collection. It's different for garbage collection for JVM, but the garbage collection for that code and for code that you don't use it in anywhere of the project, but was here for any moment, was created here, maybe was used in the past, or maybe was developed and never used it. But you can delete the code for garbage collection. It's also a type of refactoring. And the most difficult is a long-running refactoring that happens when your software is big, and turns into a monster code. But you have to make a big refactoring with, when you see many code smells and many responsibilities and many pieces of code that can maybe better with a refactoring, but you can just refactor during a delivery task or during a code review. That's another type of moment of refactoring. You maybe just a long-run refactoring and take a sprint or some days and some weeks or maybe a month to refactor our project. So you can map where you need to change your code, and maybe you can prioritize it with your backlog and make a long-run refactoring that is not too easy, like a refactor a method or just a class. It happens when you have to refactor all your project, and it takes days, weeks, or months, or maybe years to make a refactoring. It's another moment that's most difficult to talk with the business team mainly, that you need to do a long-run refactor because you can stop all the backlog for other products and other features just to make the refactoring. But it's a good moment, is a good type of refactoring that you can improve all your projects in the same time, but not big changes in some types or some features. Another type of refactoring that's my opinion is the best type of refactor, is the best moment to do a refactor, is refactoring code review, because in code review, we don't have the code merged in other projects. So you can make some adjustments and improves without the code is merged in our project, actually project. So you can make some revisions and comments in code review, and the code will be improved in Refactoring before they go to production, for example. Because we go to production, we can just talk, tomorrow I improve this code, next week I improve this code, and we never go back to improve this code. So in code review is the best moment to do a refactor, because you can just point some points in specific features to do a refactoring and also deliver a better software and better feature, improve this culture in our team, because we can merge our code and put up it in production, and after we go better. So you can just make a refactoring and deliver a feature with a code following the best practices of software design, for example. And what are the disadvantages of refactor? Refactor is too good is very good to improve software design, it fixes big bugs in productions and develop faster, but we have some disappointments and disadvantages of refactoring because we have longer time to deliver features because developer refactoring turns into a task in deliver. For example, we need to code, we need to test, and we need to refactor in the same task, in the same history, for example. So you take longer time to deliver features because you have to make adjust into a history. So you maybe can take 2 days or more days more because you are doing a refactoring. Increases the chance of large merge conflicts because you can change method structures, you can change method names and class names when you use the technical extract class, for example. You can create more classes and rename classes, rename methods, and let's go to pull request, a code reviews, we can cause a merge conflict, a big merge conflict. Is a little disadvantage of refactoring. And also, and the worst disadvantage, I think, most text needs to be rewritten. For example, you have a test that validates some business logic, so this business logic was extracted for another class, another method, or just change all the organization of the code. And the test don't work more because you change all the structure of the code, the method's names, and you need to rewrite all tests. It's a good idea to rewrite tests, but takes more long time because you have to develop a task, refactoring, and also rewrite a test to pass after the refactoring. And before we talk about refactoring techniques, it's important to talk about code smells because most refactoring techniques is to correct some code smells. And what are code smells? Code smells are indications of problems or deficiencies in the source code of a computer program. These smells could be signs of poor programming practices, poor design, or possible bugs, or just a lack of knowledge, for example. We have code smells, and when identified, code smells can be considered an invitation for further investigation that code can make improvements and refactoring also. We have a code smell that's called code duplication, when we have two methods or two classes that make the exact same things in different places of code, and we can unify this in one class, for example. We also have another code smell that's a very long method. For example, we have a method that has 20 responsibilities, 100 lines and other things. It's a type of code smells because if you have many responsibilities, you are not following the solid principles, for example, the single responsibility principle. So, for example, you have to extract this method, you extract this class. For isolate the responsibilities is a type of refactoring. We also have class with many responsibilities. That's the same idea of the method with same responsibilities. We have confusing generic names. For example, we have a method using foo, bar, and other things that we see in coding tutorials, for example. So we have methods with a name save or just A, B, C that we cannot not understand what method your class is doing for the name. It's a type of code smells. And we have irrelevant or outdated comments. Comment is a polemic topic about programming, yeah. But comments sometimes make sense, for example, for explain a business logic, a business validation. But if the comment is outdated, it don't make sense to keep in your code. So just delete these comments. And let's talk about refactoring techniques. The first refactoring technique is extract function or extract method that is used when a piece of code in a method or function can be grouped in a separate group. This function encapsulates the logic contained in the original code snippets and can be called in other places, avoiding code duplication. For example, we have a class calculator, and inside the class calculator, we have a method calculate salary that has received the salary and calculate the bonus inside the same method. Make this type of refactoring, we can just extract to another method the calculate bonus And we have a method that can be private or even public to be used in another class, for example. And now we call this method calculate bonus inside the calculate salary. So the method calculate salary just calculate the salary, and method calculate bonus just calculate the bonus. Responsibility is isolated following the single responsibility principle. And we have another type of refactoring that is structure variable. That's used when we have a complex expression in a piece of code that can be extracted into a variable with a descriptive name. Always remember to use a descriptive name. So you identify an expression that it is difficult to understand or that it is used multiple types of code. For example, we have a variable that's used many times in many methods, and we don't have a global variable, for example. Then you extract it to a separate variable and give that a meaningful name, always. For example, we have some informations that calculate the unit price, quantity, and discount. So we have to calculate the discount, for example. So we can use the variable directly, or you can isolate the variable to make this calculate of discount or price without discount and the value of discount in a variable. So instead of you made this calculate for discount in every type you use this value, you can just call the variable, and this variable will already make this calculation for us. For example, we can have a variable total price without discount, another discount value, and another total price with discount. So you can use this variable instead of made this calculation every time you need to calculate the discount. Another type of refactoring is its encapsulate variable. Use it to encapsulate a variable, making private and provide access methods or getter and setters in Java to manipulate it. This technique helps to improve data access encapsulation, control, and consistency of our code. And how it works. You identify a variable that's being accessed directly from outside the class and make it private. You then create getters and possible setters to interact with that variable. For example, you just create setters when you know that you need to make a setter into a variable, into an object. For example, if you need to make a put method, actualization, or change some value, you need to create a setter method. But you can, if you just access the value of this variable, you can just make getter methods. So don't use public access method, but create setters when necessary and getters when necessary also. For example, we have a class called cluster, and we have some attributes called name that's public. So we can control access creating this variable name as private and create a getter and setter. So when it's necessary, you call the getter, and when it's necessary, you call the setter, but you don't have a public variable in a public class, for example. Another type of refactoring is introduce parameter objects. Is used when a set of related parameters are being passed repeatedly to a method function. So you have a method or function that use many parameters that you can change each star into an object, for example. This technique involves creating a new object that encapsulates these related parameters, simplifying the method call and improving code readability. You identify a set of parameters that are frequently passed together and group into a new object. In this new object is then passed as a single parameter into the relevant method or function. For example, we have a method send emails that always we pass the recipient, the subject, the content, and the sender. Instead of pass all this variable, you can create an object called email, and instead of you pass these parameters, you pass the object email and set using setters the variables and the attributes of this email. So in the method, we can just pass public void send and pass the object email inside of this instead of the variables or the parameters isolated. And we have another type of refactoring that is split phase. This is used when a method or function performs two or more distinct phases or different types of tasks. It's important to say that split phase is not following the single responsibility principle, because you have many phases and also many responsibilities in your methods. For example, you have to involve separate these phases or these responsibilities in separate methods or functions, improving the readability, modulability, and maintainability of the code. For example, you identify the different phases or type of tasks that being performed in a single method or function, and then we extract each phase into a separate method or function, allowing it to be more focused and specific in its responsibility, and also following the single responsibility principle. In this example, we have a method called process order. In the same method, we are having the logic for validate the order, the logic to update the stock, and the logic for send the order confirmation by email. So many responsibilities in one method, as you can see. Doing this refactor, we can separate this and other methods. For example, we have another method called validate order, and inside this method, we implement all the business logic and validate to validate an order. For example, check the credit card limit, check we have money in the account bank, for other things. And after, we have another method called update stock. When you go to update the stock, we have, after we have the deliver some from product, and we have this product was sold out, for example, or no. And we also have another method with the responsibility to send order confirmation by email. So we can make an integration with a tool for send emails or another microservice that will send email, for example. And after we separate this method, we call these methods inside the process order. So we call in the correct order, right? The validate order, and after the update the stock, and after the confirmation by email for the order. So now we are following the single responsibility principles, because instead of you have the code of all these validations and these phases for this technique, we are separated methods that are called in the specific moments and also can be called for another class, helping us also in the reusability of the code. And another topic of refactoring is extract class. That is used when a class contains many responsibilities, is not following the single responsibility principle, and can be better organized in a new separate class. This technique is involving creating a new class as transferring related attributes and methods to a new class. For example, in this type of refactoring, we can create 2 or more classes from one class. If we have one class that we have 4 responsibilities or 5 responsibilities or 10 responsibilities, we can create each class for each responsibility and also extract the method related to each responsibility from each class that is from this responsibility. It's this simple technique of refactoring, I think, is extract class and extract the method. We can just extract a class, and also ideas from developer help us to make this type of refactoring. In IntelliJ, for example, we can just separate a piece of code and extract the method, or also extract the class. I think we can just make this automatically from IDE, for example. And we have another technique that is remove middleman. It's used when a class acts as an unnecessary intermediary between other classes. This technique involves eliminating the middleman, allowing method calls to be made directly between the relevant classes. For example, we have a class called sale and we have a class called seller. So we need to have a calculate of commission, and we can call this method for calculate commission for class seller. Made the refactoring, we can change this and also calculate this commission inside the seller class, but without calling the method, we can just call the attribute get commissions that be already calculated in the seller class. We just remove an intermediary or a phase that is not too relevant for this case. And another type of refactoring is hide delegate. It's used when a class is providing direct access to a delegate object that direct access is being overusing or violating the principle of encapsulation. This technique involves hiding the delegate object behind these methods, of the class that encapsulates limits direct access to the delegate. For example, we have another type of refactoring that's movie function that is used when a function or method is located in a class that's not the most appropriate for this. For example, we have a class that processes an order, and you have a method or function that just create a new client, for example. This is not the best place to be the method. So we can just extract the method or move this function to a class or to a service also that will be responsible to validate or create a client or consult a client for other responsibilities of a client, but separate from the responsibility for orders, for example. This technique involves moving the function to another class that has more appropriate responsibility or where the function can be more easily reused. So it's most important that we can also need to think to reuse of the code. For example, sometimes makes sense to create a public attribute or a public method for being reused in another topics in another place from this project. But sometimes just create private also. And another type of refactoring that is remove that code that corrects the code smells that code that I say before. Is used when there are sections of code that are no longer used and no have impact on operation of project. This technique involves removing these unnecessary code snippets, simplifying and making the code cleaner and more readable. And another type of refactoring is change value to reference. For example, is used when you have an object that is used as a value, but then you realize that you need to treat it as an object with its own identity. This technique involves replacing the value representation with a reference representation, allowing multiple objects to refer to the same instance. For example, we have a class called person, and we have the attributes name and age. We can just make a constructor or getter and setter and other types of customizing of the age, for example. But we can also extract the age attribute for our age class and also made some age validations and age, some things of age, some age validations if it's an adult, for example, and other things. And instead of you have the attribute age in the class person, we can have the class age and made an attribute age, made a constructor or more than one constructor for this age, for example. And another class is the compose conditional that says you use it when I have a complex condition with multiple brains and the logic becomes difficult to understand and maintain. Brains is not brains from Git projects. Brains are decisions. For example, we have if, and inside there's if we have a switch case, and inside the switch case we have another if. For example, is a type of conditional. There's a complex conditional, and if else inside of another if else, or a switch case with 100 switch validations, for example. This technique involves decompose the condition into smaller, clearer parts that make the code easier to understand and maintain. For example, you can make separated if and else validations and separate switch cases and also separate in another class and another method. And each method we will do separated if and else and switch case. There are another method validation and conditional code. In each method, they're not just an if inside another if, inside another if, and another things. Introduce assertions is a type of refactoring that I am not like too much, but she is much famous. It's used to add assertive checks to the code to detect and capture errors or invalid states during development and debugging. This technique is not using these two-string methods, for example, that just validate is null, is empty, or other things. This technique introduces assertions. Also, we have in assertions in unit test, for example, we can use assertions from JUnit, anchors, and other things. This technique says that you can introduce assertions inside your code and not just in your test. I don't like too much this technique, but it's a type of refactoring that sometimes can make sense, but I never use it. You introduce assertions to validate a null value, a equality, and other things. but you can use toString methods and other validations and other class or type of validations, start use assertion directly, but have a type of refactoring. And also we have a technique that's called replace constructor with factory methods. Is used when you have a class with one or more constructors that can be overridden by a factory method. This technique involves creating stacked functions that encapsulate object creation, providing more expressive and flexible interface for creating instance of the class. For example, we have a class called product. And inside the class called product, we have two attributes, that's name and price, and we have a just simple constructor with our args in this constructor. Making this refactor, we can change for creating a production. We can create a method that will be also a constructor, but is most a factory method. In this method, we can validate the price. For example, we can receive the name and the price and validate if the price is less than 0. And if is, we can throw an exception, an illegal argument exception, or a customized exception, for example, that is an invalid price. And we can also validate the name. If the name has less than 5 characters, for example, we can throw an exception also. So instead of create just a constructor, we can replace with factory methods with customized validations and other things. We have another type of refactoring that is pull-up method. Is used when you have similar methods in a subclass and we want to move them to a separate class. We have to pull up the method to avoid code duplication and promote reuse. So starting off, you have the same method, and now the subclasses, we have one method that can be overridden, extended, and implemented by the subclasses. This technique involves moving a method from one or more subclasses to the parent class, the superclass, making common method that can be shared by all subclasses. For example, we have a class called developer, and this class was extended by front-end developer and back-end developer, and see that in the front-end developer and back-end developer, we have a method called write code. You can see they make the exact same thing, code duplication and code smells. Making this refactor, we can just extract this method write code from the developer class, that is the superclass in this case, and we can just extend this class and use this method by overriding this, and you can just call the method write code and personalize the implementation, for example. But we don't have to write the code, the method write code, 2 times or more times in this project. We can also make this using interfaces, not just class, for example. So instead of made the same method in a now class that implements some interface, we can just create a method in the interfaces or just implement the implementations inside the class that we will implement this interface. And we have another type of refactoring that is extract subclass. Is used when you have a class that is performing functionality that is specific to a subject of objects in this class. This technique involves creating a new subclass that represents this specific subset of objects and move the relevant functionality to the new subclass. For example, we have another type of refactoring that is collapse hierarchy. That is used when you have a hierarchy of class where differentiation between subclasses become unnecessarily relevant. For example, you extract a subclass from a parent class, that now you have a big hierarchy for a class. For example, a class that extends a class that extends another class, and you have another class that extends the first class that extends for the first superclass, for example. So we create a complex hierarchy in our code. So this technique involves removing one or more intermediate subclass, moving their attributes and methods directly to the parent class. For example, we have a class called animal, and we have a class called mammalian that extends for animal. In this example specifically, let's say that we have just mammalian animals, okay? So we have an animal called a dog that extends from mammalian, that extends from animal. And we also have a called class that extends from mammalian, that extends for animal. Made in refactor, we can just remove the mammalian how I say, let's consider that we just have mammalian animals and all the animals will have the same behaviors because all the animals will be mammalian. So we can just extend directly for animal and extend directly for animal, the dog and the cat class, and we can just remove the hierarchy and remove the mammalian class, for example. And what is the conclusion of this presentation? Each refactoring technique aims to solve a specific problem and they must often to be applied together. So we can use a mix of refactoring, we can personalize the types of refactoring, we can use refactoring techniques and also the best practices of programming with code, clean code, with solid principles. I say many times about solid principles, so the single responsibility principle, I think, is the most principle that we can more use to archive them using refactor, because you can extract and move in function and reduce and other things, and following the single responsibility principle, but also the another solid principles, we can follow the keys principles and other best practices of programming doing refactor. And also it's more easier to implement design patterns, for example. And this refactoring technique I take from the refactoring book from Matt Fowler that have many other types of refactoring. Here I bring just the principles and the most used in the market. So we can also have some examples in the site of Refactoring Guru, what my references for this presentation. And that's it, guys. This is my social network in this QR code. So you can just add my LinkedIn, YouTube, and other channels. And thanks for watching, and thanks for the opportunity to present in this event also.
Hi again, Camilla. And thank you so much for the talk and also for getting up for us, since you're based in Brazil, if I'm informed correctly, and it's pretty early in the morning, what I saw earlier. All right. So I hope this was a good wake-up call for you, this talk. And I also got some questions for you. So if you still have time for a short Q&A.
Okay.
Perfect. Then let's start right away with the first one. When it comes to refactoring, how do you decide which part of the code base to tackle first? Are there any strategies or best practices you recommend?
Okay. If we are doing a long time in refactoring, I just see the worst thing in the code and choose the worst method and the worst class to do a refactoring. But if I do a refactoring during a code review or during a develop some feature, I just choose the part of code that we change for deliver the feature, or I will change for review our code, for example. So I can just choose from the moment, for example. So if it is in the developer feature, I choose a class that I will already change the class for develop a new feature, or I will change this method for a code review, but it's a long-term refactoring or a refactor for understanding. I will doing conforming. I will see a bad code or a better bad practice of code, for example, and I will change this how I can see the bad code, for example. Depends of the moment of refactoring.
Yeah, all right. Thanks so much for this answer. We got another question. Can you give us an example of a situation where the split phase technique is beneficial in refactoring code?
For example, when we have some business validation in the same methods. In my project, for example, I have a method that has, I think it was more than 50 lines of code, for example. Then we call it another methods when we are calling some validations, and maybe this validation inside the same method, for example. Using the split phase, I separate it in other classes and other methods, and I call these methods from the big method, let's call for this. So using the split phases, you can isolate the responsibilities in another methods and another class also, if it makes sense. And we can reuse these methods in another places. So you don't have a validation inside of the method, but you have a validation in a public method, for example, in a util class, or a class that can be used in another place, for example. So using split phase, you can make the code more easier to understand because you have the called from methods and not the implementation of the methods inside the same method. And we can also use these validations in another places from the project, for example. I personally like too much the split phase, and I applied this technique last week in my project.
Right, awesome. Thank you for these answers. Well, Camilla. And let's go on to the next question. Change value to reference is an intriguing technique. Could you provide an example of when it's applicable and how it enhances code maintainability?
Okay. Change value to reference, it makes sense when you have many parameters, I think, because you just have 3 or 2 parameters, don't make sense. But you have many parameters and you can just create this from an object. And you also you need to use this object in another place, for example. You don't use just in these parameters. So when it's applicable, I think when you have some many parameters, and also we have many methods that use the same parameters, for example. So we have many methods that was overridden and just a modification from implementation, for example. And we have the same parameters in the many times of the code. So instead of you writing many times the values and attributes, you can just change to use the object directly. So you have a little bit of attributes, or you just have a one method that uses this attribute. I think don't make sense to use this technique, but you have many attributes, for example, 10 attributes, or we have many methods that use the same attributes or most of these attributes. I think makes sense to create an object and makes more easier to understand, I think, because you just can get inside this object and see what the attributes is inside them. Inside we have the many attributes and the same sign of the method, for example.
All right, thanks for clarifying this as well. And we have one more question, but this might be a really short one. Where can I get the slides of these? I really like the refactoring one. Maybe you can share them on your socials or something?
Yes, I will post in my LinkedIn today, I think. A little hours after this, I will post in my LinkedIn and Twitter and other social networks.
All right, then make sure to check out Camilla's socials. And Camilla, thank you so much for joining us so early today for you. I hope you had a great start in the day and hopefully see you soon on another live day.
Yes, thanks for the opportunity for talking this event. And I like to be here more times.
Yeah, let's do this. All right. Camilla,
have a nice day.
Next time. Yeah, have a nice day. Bye. All right, and before we end the Java Developer Day, we have a little surprise for you as we invited one more guest. He's one of our community partners. Welcome, Martin.
Hey, everyone. Hello. Can you hear me well?
Yes, I can hear you perfectly.
Nice. Thank you for having me.
Right. I think there are some connectivity errors on Martin's side. Hello? You are back, yes.
I was just saying thank you for having me at the event. I would like to share some interesting insights from my side as well.
Yes. Since I already told the audience that you are one of our community partners, which community are you exactly from?
Yes, exactly. I'm one of the guys that helps organize the events in the Bulgarian Java user group. We've been now doing many different kind of events in the last more than 12 years. And the community itself is way older than that. So what we do typically not only meetups with speakers from all over the globe, we do some informal gatherings simply over a beer, or just to do some small hackathon, let's say update the website of the community, to contribute to some open source project. We also have our own community conference called JPrime, which runs every year around May, and gathers around 1,200 developers. So the community can get together and watch some nice sessions, get into networking discussions, and so on.
Right. That sounds fantastic, Martin. Maybe I can ask you what inspired you yourself in the first place to join such a community, a software development community?
All right. So at the time I started getting involved with the community, in fact, there was little to no activity in the community. So the people that originally founded the Java user group, there is like many Java user groups across the globe. And ours, I tend to say, is one of the old ones, but for a certain period of time, over a few years, there was really no activity, no sessions, nothing. And at the time I was working at a company and I had an interesting idea to make a session about. At the time it was about Eclipse plugin development. So I did it with one more guy that was interested in that topic. So we started doing sessions at the universities, primarily here in Sofia. After a certain time, we started making sessions every 1 or 2 months, and we decided to get more involved and try to create a community conference. And that's how we started doing JPrime. Me personally, I started also speaking at other Java conferences, and now in the last 10 years, I've been involved in quite some other events and communities, primarily in Europe, but also some events in US and other countries. So that's how we pretty much started. We just decided to start doing sessions to share some interesting knowledge with people. And slowly over time, we saw that there was quite some interest. So we had around 50 to 60 people coming on the sessions, which I think is, for a community gathering, that's quite good. And then we started doing more events of this kind.
All right, sounds fantastic, Martin. And maybe can you break down what, in your opinion, might be the main benefits for software developers to join such communities as yours?
Absolutely. So for me personally, it was not only a way to do knowledge sharing, but also to expand and enrich my skills as well. So in many cases, when you do a session or a hackathon or organize a technical event, you need to be quite well prepared. And that requires you to go in depth into the particular topic that you look into. So for me personally, that was a great opportunity to also enhance my own skills at one point, and the other to share knowledge with other people in the community that might benefit out of that. The other really good reason for that is that you gather with like-minded people. So you, of course, that's probably the best opportunity that you can have, like an environment of people that are, I would say, at one point friends, and at the other point colleagues and professionals that you can exchange knowledge with. So it's like another good aspect of being part of a community.
That's so true. Yeah. Sorry.
Yeah, I was about to say that these are the primary reasons I got involved that much with the community. But yeah, it's of course a lot of fun. So.
Talking about like-minded people, you already told us a bit what you're doing, but maybe you can specify on what projects and topics does your community typically focus on most of the time? All right,
so yeah, we try to keep track of latest and greatest technologies in the Java community worldwide. So we keep a close eye on the latest JDK developments at one point, and on the other, we have a look at the latest updates on major frameworks like Spring, for example, on new and really useful Java libraries, and pretty much any development that comes at the horizon. And it's something that is worth discussing and worth sharing with people. Also, over the years, we got many companies to sponsor the events of the community, including the annual conference that we organize. And many of those companies have people working on different interesting open source projects, whether that's part of their mainstream project or some side projects. And people are really willing to share knowledge about this kind of technology. So it's not only the main people that help organize the events in the Java community, but pretty much the entire community has been contributing over the years with interesting topics organized in the form of sessions or sessions during the JPrime conference. So, yeah.
Right. Yeah, so you're very, very forward focused.
Yes,
That's awesome to hear.
if we can say it like that.
Yeah, and I can assume that you already provided enough info for some of our viewers so that they maybe want to join your community. What would be the process of this?
Yes,
How
so I would say in the form of a Java user group or Java user community, most people join the community that's closest to them. Let's say this can be a community in your own city, or in some cases, like in our community, it can be community in the entire country. So we organize sessions not only in Sofia, but in many cities around the country. We also had several times where we did tours to just share some interesting knowledge and promote the technology to people in other parts of the country. So I would say that the first thing for people to look is whether there is a community matching their level of expertise around them, and join that community. There are many hundreds of Java user groups across the globe, so I'm pretty sure that there is one which is really close to you. And if you want, you can, of course, if you want to keep track of what's happening in our community primarily, we try to record every session in our YouTube channel. We have a Bulgarian Java user group channel. So all the sessions that we do at the JPRIME conference are free to watch on the YouTube channel. Also, many of the sessions that we do on community gatherings are also recorded in YouTube. And this year we also started free Java Academy that we do in our community. It's like a several-month program, which at the end provides you with a free certification that is recognized primarily by local companies here. And who knows, maybe in the future we'll expand that more globally. Because for now, this program is conducted in Bulgarian, but we plan to expand it to sessions in English. So
yeah,
these are some of the ways people can follow and see what's happening in the community and benefit from it. So
yeah, no, you have a lot to offer, as it seems. And are there any, maybe for interested people, do we have any upcoming events or activities that we should know about?
Yeah, so now next month, as I mentioned, so first thing around the academy that we do in the community, we start a third course, which is called Advanced Developer course, which covers sessions which are with advanced topics ranging from Spring to Java to messaging systems like Kafka, Axios, to other systems like Elasticsearch, and quite some interesting range of topics that get covered in this course. And everything will be recorded online. You can go to the jug.bg website and subscribe to any of the courses. There is most of the references are in English, so even if you don't follow the sessions, if you don't understand them, because they're in Bulgarian, as I mentioned, you can follow the agenda and expand your knowledge. Also, we started organizing the JPRIME conference for next year. So in May, you can just watch the live sessions online or the recordings in YouTube, because we also do live stream recording during the conference free of charge. So you can watch all of the sessions online. And the other meetups are in fact offline. So we have some informal meetups, like, for example, so-called Java beer events, where people gather over a glass or two of beer and they just talk about technology, share knowledge. It's more like an informal event where people gather together for networking. But if some of you are by chance in Sofia, there is an event every month. So we would like you to come, say hi, and we can discuss and exchange ideas on these events. And
the beer is mandatory.
The beer is mandatory, and the beer is free, because we have many sponsors and companies that organize it. So.
I see. Okay. Now I'm connecting the dots.
These events are, as you can guess, especially preferable in summer when it's cold and people really enjoy more the beer. But also, as I mentioned, there are events every month, so you can come even in December when it's too cold and still drink maybe dark beer, which is more preferable for the season.
Maybe with a lemon, it's also
yes.
Okay. And Martin, since you have that much experience already also when it comes to these communities, meetups and everything, do you maybe have some memorable moments or some funny moments to share with us?
Yes, of course. I can mention one thing, which is, something that you won't see on the news or anything, but there is a program called Duke's Choice Awards, which Oracle gives to communities and open source projects. And 2018, I was a speaker at Code One conference in San Francisco. And I realized that at the awards, they gave a community award to our community for the different contributions and events that we do, which was quite a recognition at the time. This was more or less around 5 years ago. And yeah, this is something I can mention as a milestone and a recognition for the entire community that we have. It was really a nice moment, feeling that you've done something good for the community and you have contributed to the global Java community as well. So this is one of these moments that I can mention about.
Yeah, that sounds really awesome, Martin. So, thank you so much for sharing all of this with us. I think the audience now has a better picture about you and your communities. We also linked the community via logo. Just scroll down on the live page and click on it. There you also get further information about everything. And Martin, thank you so much for joining us and providing us with all this info.
Thank you for having me. And maybe one important thing that is worth mentioning is that, because I've noticed that in my practice, many people are not feeling comfortable speaking at events or conferences. They don't know how to approach that process in general. So by joining a community, you not only get the chance to start sharing knowledge in your local community, but this also gives you furthermore access to more global conferences. So if you want to, for example, speak at another conference in another country, it's best to start in your local community to get some confidence, to get some experience speaking. And then you can start applying for other conferences, having some already community experience, and start sharing that knowledge more globally. I think that's also one of the big benefits of being part of a community.
All right. Yeah. Thanks so much for also sharing this with us.
Yeah. Thank you for having me.
For the ongoing speakers, and hopefully we see each other next time, maybe on another event or some community gathering.
Yes, absolutely. Or maybe at WeAreDevelopers World Congress next year.
Maybe at WeAreDevelopers World Congress next year, yeah. Code is on the way.
Yes, absolutely.
Martin, thanks so much and many greetings to you.
Thank you, and have a nice day to you and your audience. So thank you for having me once again.
Thank you. Bye, Martin. All right. And with that, also, the Java Developer Day comes to an end. It was the first event of this season, but don't you worry, it's an ongoing season. But before we end it, don't forget, we provided you with a code for our World Congress. We will post it again in the chat now. You can go to worldcongress.dev to get further information on the upcoming World Congress from 17th to 19th July next year, 2024, again in Berlin. So check out all the infos and make sure to claim your early bird tickets, which come even cheaper with the provided code. And hopefully we see each other again next week on the 20th of September when it's all about Angular. Until then, bye.